Okay, what's going on, everybody? How you doing? How you doing? Hello, dudes. What's going on? All right, so this is the EJ's moon landing and rocket launch review. Not in that order, though. So how's everybody doing? I'm still here in Texas. Still here. I'm still in Texas. You could tell because of the way it is.
Discovery, going throttle up.
Catching 93 month 37 at the beach. Ishiku had a 55er in there. Thanks, Ish. And Hallingar with the 71 month 37. Ewok with a 46 before that. How's everybody doing? Brimo going to have to move to Texas at this rate. Brimo does not want to move to Texas at this rate. Brimo, that's not a thing. Cheesecake and margaritas. Yeah. yeah, it's a good time. So I can confirm that I can in fact see Starship today out the window, which is good.
Discovery,
Easy.
going throttle up.
44-month resub. Thank you. I can in fact see it. See Starship out the window. If anybody's trying to figure out like why I'm not in mission control, it's because I'm on location at the Margaritaville Hotel on South Padre Island. I can see Starship. We can almost taste it. Anyway, which airport did you fly into? One with runways. One with runways, dude. Hey, Arp, what's going on, man? This stack is cursed. Yeah, some very interesting stuff happened yesterday that involved a hammer. Can you see Starship? I can. But I'm doing this space kind of impromptu. Well, not impromptu. I planned it. I'm doing this space news today because we do have VA-263, the Ariane 6 launch. You know, that's nice. It was a simple question. I gave you a simple answer. It's either Harlingen or Brownsville, Snickers. It's one or the other. I don't want to say. I don't want to say. I assume it tastes like a stainless fork. Yeah, maybe. I don't believe you still are in Texas. That totally looks like a green screen background. It's not. I swear. How you doing? I'm all right, Maddie. How are you? So we have the Intuitive Machines lunar landing, and then we have VA-263. VA-263 is live, so we can go see what they're all about. So let's jump in and do that. Oh, look at that, an Ariane 6. Look at this.
David, what's going to happen after that?
So yes, Ariane 6 will lift off.
It's a nice lime. Thank you. Nice hat. Yeah. It's pretty good. Yeah, I mean, S Master, you asked if we have any space news today. Yeah, Ariane 6 is launching.
Fairing separation.
Isn't that great?
After that, the main stage will fire up to 7 minutes and 40 seconds. And
isn't this? Look, aren't you excited?
Will be followed by the Vinci upper stage engine, which will be ignited for the first time, and
yeah,
for 11 minutes.
Aren't you? Look at how excited the chat is.
After that, we will have a long coasting phase and an additional boost of just around 30 seconds. And after that, once we are positioned in the right orbit, we will be able.
You're very excited.
Separate CSO3 in.
Yeah, isn't this great?
After that, the upper stage will enter a new coasting phase before a third boost, which will slow it down, and this will be followed by stage passivation, and leading to a re-entry of the stage above the Indian Ocean. This additional deorbitation boost avoids any debris, which of course is very important.
Absolutely.
Absolutely.
Absolutely, very, very important indeed. And of course, once CSO
All right, let's see what we got here. We're 21 minutes out.
And the clue to what the CSO program
All right.
does is in
The
its
board's
name,
looking
optical
green.
space component, very much a French program for observation and defence, built by a consortium led by Airbus Defence and Space, with Thales Alenia Space in charge
When someone
of
like
the
this launches, do they
optical
have
instrument. So, a
done get
very
with the
important
FAA? Do
programme
they have
for the
their own
French
entity?
armed
They have their
forces
own
and indeed
entity
for their
like them, but they're
partners.
working with. Did they just cut the audio, or? Starship is today, is Phil, as far as I can tell. We haven't heard official word yet, but we'll let you know. Their cast just
20 minutes and
stopped.
30
Okay, there we go.
seconds to launch. A beautiful image there of our rocket on the pad. Ariane 6 for its second launch.
Yeah, Trin, I see that.
Aujourd'hui indispensable à la planification et à la conduite des opérations militaires, les capacités spatiales sont pour la France une priorité nationale. Alors que les menaces se diversifient et s'intensifient, elles assurent aux armées une bonne connaissance de l'environnement stratégique et tactique et contribuent au succès des opérations. La stratégie spatiale de défense et les lois de programmation militaire visent à doter la France des moyens nécessaires pour défendre notre liberté d'accès et d'action dans, vers et depuis l'espace et garantir notre souveraineté. Soutenues par le ministère des Armées, les technologies de pointe nécessaires ont été développées pour permettre à la France de disposer de moyens spatiaux parmi les plus performants au monde. Le lancement du satellite CSO-1 en décembre 2018 a marqué le début du cycle de renouvellement des capacités financées par les LPM précédentes.
I tried to lean out of the way so you could see it, but I have no green screen. Sorry.
Le lancement de CSO-3 clôture ce cycle. Sa mise en orbite permettra d'accroître les capacités d'imagerie militaire.
Les satellites CSO font partie du programme MUSIS, dont la maîtrise d'ouvrage est assurée par la DGA.
Engineer.
Elle a délégué au CNES la
Can you
réalisation
translate for you? Yeah.
une fois CSO3 réceptionné.
Yeah, sure.
Le système complet
Once CSO3 has been delivered and
pour répondre aux besoins
service with the armed forces and immediate to general staff. 6 years after the launch of the first CSO satellite, CSO3 completes the constellation. The performance of this third satellite is identical to that of its predecessors and is at the current leading edge of technology and industrial experience in optical Earth observation, unrivaled in Europe. CNES and our industrial partners, Airbus and Thales Alenia Space, have now reached maturity in their ability to develop and operate such increasingly complex space systems, meeting the increasing demanding needs of our armed forces. As a result, the system is about to enter its operational phase, scheduled to last at least another 10 years, with CNES playing an active role in ensuring its operation and quality of service. CSO satellites are the fruit of Europe's fruit, bananas.
d'observation optique spatiale en Europe. Leurs caractéristiques inégalées permettent d'échanger de l'imagerie radar avec l'Allemagne et l'Italie et d'offrir ainsi aux opérationnels français le meilleur de ce qui se fait en Europe. D'autres pays participent à la coopération, permettant de construire l'Europe de la défense en offrant à tous ces pays le meilleur de ce qui se fait en optique visible et infrarouge spatiale.
L'objectif des satellites est d'offrir aux forces les images nécessaires pour suivre
Okay, I'll just let them
et
talk.
anticiper les guerres de demain.
Dans un monde marqué par l'incertitude,
Lieutenant Colonel René.
de nouvelles menaces et caractérisé par le triptyque compétition, contestation, conflit, les armées ont besoin plus que jamais
De Gaulle.
d'appréciation
Look,
autonome
it is
des situations.
de
La
Gaulle.
capacité militaire d'observation de la Terre contribue avec d'autres moyens à répondre à cet impératif. Elle est actuellement constituée de 2 satellites identiques CSO-1 et CSO-2, employés dans des missions
CSO-1.
complémentaires de reconnaissance
CSO-2.
et d'identification. Plus précisément, elle permet de détecter, de reconnaître, d'identifier et localiser tout objectif d'intérêt de défense, de générer des données à des fins de renseignement, de ciblage et de géographie, de jour comme de nuit, en tout point du monde, dans un rythme compatible avec
They're Earth
des opérations.
observation
Sous la
satellites,
responsabilité
guys,
du
for
commandement de
military
l'espace, le système CSO
military intelligence
participe également à
satellites.
l'appui des opérations militaires en fournissant une imagerie optique visible et infrarouge, fiable, précise et au bon moment.
Les
Et
images
au
des
bon moment.
satellites CSO sont utilisées par de nombreux services de renseignement, principalement la direction du renseignement militaire. Le système MUSIS est en service depuis 2019
Les
et fournit
secrets.
depuis plusieurs centaines d'images quotidiennement.
Nous évoluons
Précis.
dans un monde toujours plus conflictuel où les capacités d'observation de la France sont pleinement sollicitées. Grâce à CSO3,
Oh, look at this guy.
la direction du renseignement militaire pourra acquérir davantage d'images, de jour comme de nuit. Cela améliorera
Oh,
également
dude,
le
this
délai
guy is
entre
super
deux prises de
secret.
vue sur un même site
Look
internet.
at the super
Le traitement de
secret.
ce flux additionnel d'images électro-optiques et infrarouges est facilité par les outils d'intelligence artificielle. Cela va améliorer la quantité et la qualité du renseignement produit, ainsi que son partage. Ce troisième satellite de reconnaissance consolide notre crédibilité auprès de nos partenaires les plus avancés dans ce domaine. C'est notre
We have 3
autonomie
launches
d'appréciation
today.
de situation au profit des autorités politiques, des décideurs militaires, ainsi que de nos forces déployées, qui
Excuse
sera
me.
renforcée, de même que
let me
notre
check.
résilience.
La DGA prépare déjà la génération suivante avec le programme IRIS qui prendra la relève à partir des années
No.
2030. Avec ses
2.
satellites aux performances
CSO3,
et
which is
réactivités
what we're
accrues,
watching
il
right now.
permettra de poursuivre les
Starship,
missions de CSO
hopefully.
conformément à la
And then
stratégie
we have a
spatiale.
lunar landing.
Tout comme Helios et
IM-2
CSO, le programme
after
IRIS
this
s'inscrit dans
launch.
une logique de coopération en partageant nos capacités d'imagerie avec nos partenaires européens. Il promeut également une logique d'export de nos satellites au profit de nos alliés.
Aux côtés des satellites de télécommunications Syracuse et les satellites de renseignement électromagnétique CERES, les satellites CSO
Les
accroissent
satellites.
considérablement la supériorité opérationnelle de nos forces sur les théâtres d'opération. Ils permettent à la France de disposer d'une plus grande autonomie en matière d'appréciation de situation et de décision.
So, yes, a very, very important satellite up there inside Europe's newest
Look at
rocket.
Discovery,
Six.
go and throttle up.
Yes, it's
Limbo.
the second time Ariane 6 will lift off from the new pad here at the Guyana Space Center, so it's an important launch for all of us.
It really is. And designing and building a rocket like Ariane 6 is a monumental task. It requires collaboration and expertise, well, from lots of different fields, really.
It involves engineers, scientists, technicians, project managers, and lots of other specialists, all working together to make such a complex project a reality.
Indeed, from intricate designs to the precise
Nice, Alan Gar.
manufacturing of components.
I'll check it in a
every
second,
step
bud.
requires meticulous planning and teamwork. Let's have a listen in now to some of the teams involved.
Yay. Pause. Search. What the hell is going on?
Imagining Ariane 6. Imagining a heavy lift launcher. That's an immensely complex challenge. Weight, performance, power, payload capacity, etc. Everything has to be optimized with extreme precision to meet extreme conditions. For
What?
instance, the use of liquid propellants at super low temperatures.
What is...
Or the thinness of the center core's aluminum casting. Less than a centimeter thick, it must be able to withstand the rigors of spaceflight. Ariane 6 is a symbol of robustness and reliability. With over 600 companies, including more than 300 SMEs involved in its design and production, it's a truly European endeavor. Behind this cooperative effort lies a huge challenge, coordinating all the expertise, managing the huge range of partners and manufacturers so that every stakeholder can contribute their unique know-how to the project.
But as long
That's
as
what
France
European space
contributes the
engineering
most.
is all about. This rocket takes shape all across Europe. The launcher's propulsion systems are built in Vernon, France. Les Mureaux provides the main stage. The high-temperature protective structures and booster propulsion systems are designed and made in Bordeaux. The fairing is integrated at Europe's spaceport in Kourou, French Guiana, and the upper stage is manufactured in Bremen, Germany. Each partner plays their role in making Ariane 6 a uniquely capable, perfectly optimized, high-performance heavy-lift launcher. All the components then arrive at Europe's spaceport in French Guiana. This is where the launcher undergoes final assembly. Every millimeter matters, and this process is carried out with absolute precision. Ariane 6 stands ready on the launch pad, ready to write a new chapter in European space.
And there she is on the pad, 11 minutes and 41 seconds to launch. And the teams here in the fishbowl, what we call the fishbowl inside that glass, some of the teams from Ariane Space and Ariane Group who are responsible for our rocket. There they are. We call this...
What just
flight
happened?
desk, David.
Yes, here we have the CEO and CTO
What?
of Ariane
I don't
Space.
understand.
We also have Ralf Stucker, who is precisely the head of launcher exploitation at Ariane Group, so in charge of delivering and building the launcher here in French Guiana.
Is their
Yep,
sound
very
too low?
important job.
Yeah, it's
Boards
a
are
little
green
low.
there. You can
Here, I'll
see
try to
them
turn
on
them up.
the panels. We have a number of control rooms on the job today, some in
Let me
Europe.
try to turn them up.
We have 2 here
There we
in
go.
the Space Center. We've got mission control.
Let me
we've been
just check
looking
my
at in
volume
charge of the
controls here
mission,
too, real
and
quick, dudes.
closer to the pad is launch control. What are these folk doing, David?
Yes, this is the CDL3. This is the place where the teams are getting the launch
All right, I
pad
can
and
boost
the
their
rocket
sound. Give me one
ready
second.
for liftoff. These are the operations team. They are
we
sending the
go.
various commands to turn the launcher avionics on, to fill the propellant tanks, to pressurize the tanks,
Is that good?
and to do all
They
the
should be
necessary
maybe
checks
just
to
a tad
confirm that
soft
the
at this
launcher
point.
is ready for launch. And behind them, behind the glass windows in the back, the engineering teams are monitoring all these operations
Just a bit
closely,
loud? All right.
making sure that all parameters are as expected. They are following all physical parameters, temperatures, pressures,
You really want this hat? It's a pretty good hat, right?
And all these teams are also being supported in Europe
Killer.
by some additional teams who are there to help in case of need.
The more the merrier. Always good to have lots of people
Hey,
on the
Kelly,
job.
what's up?
We had the final weather check about 10 seconds ago at T-10. The weather board is
No, not loud, it was
green,
good.
so
All right.
that's good news.
I'll meet you halfway to
Obviously,
where
weather
we were.
conditions must
There we
be
go.
right for a launch to go ahead. And
I ain't
we
touching it
are,
again.
Of course, in the Amazon rainforest, on the edge of the Amazon rainforest here on the coast of French
Does
Guiana.
this have
so it
different
obviously does
configurations?
rain a
You can
lot,
run it
but
with
rain isn't
2
a
or 4
problem, although there are other
SRBs,
things we
and I
need to
believe a
monitor, aren't there?
plethora of different
Yes,
fairings.
that's right. We monitor.
How are you
high
feeling about
altitude
Starship? I
winds
can see it.
between 10
That's a
and
good
20
sign.
Go and
kilometers.
throttle up.
We need to make sure that wind speed and direction are below a certain limit. Not because the
back
launcher
up?
could not withstand it, but for safety reasons in case of any launcher malfunction.
115 months.
And we also monitor
Thanks,
lightning
man.
risk during the ascent.
Slimbo
to
had a
avoid,
54 in
being
there,
hit by
too.
lightning, of course. Here on the ground, we have the launch mast, the lightning mast that you see in the
Still a little
images
windy.
here.
The
we
wind
are
isn't too bad.
protected.
You can see
Better
here
than
the
it
weather
was. It was
centre
very
at the
windy
base.
yesterday, like that.
That's right, and from here we launch the weather balloons that you see
Les
here.
ballons.
They are sent up into the atmosphere with sensors to capture atmospheric temperature, pressure, humidity. And from
No,
this
I don't
we're
think
able
you
to
can launch in a
predict,
single stick
precisely
goalie.
what the conditions would be for launch.
Discovery, go and throttle up.
Another question coming in from Patasensa. What's
French
the
invader.
difference between the Ariane 6.2 and 6.4 version?
Yeah, so we have two
months.
versions of Ariane 6
Thanks, man.
with either 2 or 4 boosters, depending on the launcher performance
I
that
have not
we
seen it,
require
Andrew.
for the mission.
No.
Today we only need 2, considering the satellite mass and the targeted orbit.
Now, teams have
Les
been
ballons.
working here at the base preparing
What's up,
the
RT? How you
rocket
doing,
and
buddy?
the satellite now for some weeks. We call that process the launch campaign.
Discovery,
Badger.
go and
Just
throttle
talk
up.
us
What's up?
through some of the events, some of the
64-month
things they've been
resub
doing,
from
David.
Pop. Thank you.
Yeah, so here you see Canopé, which is the new cargo ship, a
Canopé.
hybrid using sails that has transported the rocket stages from mainland Europe to French Guiana. They arrived here end of
I
November,
don't know, where's
and
maybe?
they were then transported by road to the horizontal assembly building that you see here in this building. The main stage and the upper stage
Yeah,
are
Canopy has
mated
sails.
together.
It's a
We
sailboat
do
with
the
engines.
the mechanical connections between the 2 stages, and afterwards the electrical connections. And once this is ready, the
Discovery,
Chicken
go
head.
and throttle up.
stage is transported to the launch pad. There is 800
Thanks, buddy.
meters, and we use this automatic vehicle to transport the stage to the launch pad. We are then lifting it up and putting it on the launch table, from which it will take off. The boosters are added to the launcher to complete the assembly of the launcher. On the satellite side, CSO-3 arrived by plane to French Guiana. It was mid-January. It was then transported to the satellite preparation facilities, where it was checked, it was fueled.
They're fueling it up with
And,
hydrazine.
once all of this was ready, it was integrated on the satellite.
That's, them
adapter, which
attaching-
is the interface between the satellite and the launcher.
They attach it to the payload attachment fitting. The adapter goes to the PAF right there, and then there's fairing encapsulation. Sorry, I'm just trying to talk. Vertification. Yep. And then once the encapsulated fairing moves to the integration area, and then it's lifted up, and then they put it on top of the second stage. And they bolt it together. Hey, drummer. That's right. It goes in the square hole. That's right.
8 seconds now to launch. But actually, the final countdown started around about 10 hours ago. There were a lot of operations during that time, weren't there?
Yes, the countdown started a few hours ago with the mobile gantry rollback very early this morning, 8.5 hours before launch. After that, all the propellant lines were
You know, hydrazine is used to make spandex fibers.
cooled,
No, but that's interesting.
And then the fueling of the launcher started
The building moves,
around
Ditch.
5.5 hours before launch.
So the integration building is a mobile service structure. It can move. It's on hydraulics, and it lifts itself up and moves back. À tous des DDO.
Lanceur.
Compte final des lanceurs.
Top à 0 moins 5 minutes.
T-minus 5
The
minutes.
Range Operations Manager, Alex Serk, has announced the beginning of what we call the
Stop.
synchronized sequence, or the automated
That's right,
sequence,
Ditch. Yep.
or automatic
Mobile service
sequence.
structure. Builds it
Ariane
right on the
6
pad.
is now becoming progressively autonomous, and again, a whole range of very vital
Okay, range
operations
looks
now
green.
during this time, David.
Everything looks good.
Yes, all those
There are
operations
no
are very
red
precisely
commit
timed,
criteria.
combining system checks, pressurization of the cryotanks, activation of different systems and valves, and the control of the operations is
That's right,
gradually
Psycho.
being
Yeah,
handed
that whole
over
building
from the
back
ground
here, Ditch, the
computers
gray
to
and
the
white building.
onboard computers.
It picks
These
itself up and then it
onboard
moves.
computers will actually send the last commands to ignite the main engine to check that it's working.
Yeah, it's a little
properly,
froggy.
and then
Froggy
it
isn't a
command the opening of the cryogenic
deal
arms
breaker,
and the
though.
ignition of the boosters just before liftoff.
This is in
Those are
French
those yellow
Guiana.
ones you
It's in
can
South
see up there
America.
attaching to the rocket.
Hey, Alleviate.
And as we said,
I'm
we've
still
got
in
a number
Texas,
of
yes.
different control rooms on the job, and some of those in Europe.
Don't they use fireworks
This
to
is the
light it?
team
No,
at
that's a
Evry,
hydrogen
Ariane
purging
Space Team in
system.
Paris.
Yes, this is headquarters in Paris. Lots of
Look
people
at how
that
happy
have
these
worked
people
in the
are.
preparation of this launch.
Hello, everybody.
they're so happy.
Looking forward to the launch there. We've also got one of the Ariane Group sites in Ottobrunn in Germany.
Yes, this is Ariane Group's European Center of Excellence for the development and production of rocket engine combustion chambers.
Go Ariane. Lots of support from there. And let's say hello now. Hello to everybody in Bordeaux, in France, another Ariane Group site.
Yes, there are several Ariane Group sites in this region in charge of booster engineering and the preparation of booster parts and high temperature materials.
Fantastic, everyone showing all their support.
Look
there.
at how
Go
happy
Ariane
people
6.
are for rockets.
So, 3 minutes and 5 seconds now as we get closer to launch. Some excitement there in the various different centres, but we've got some very high concentration levels back here at the Guyana Space Centre, where we're getting very close now. A couple of things to look out for, David.
Mandatory excitement.
The two-thirds
Is there any good
rocket,
news from Ariane 6? I mean, it exists. Chem, it exists, bro. It's there. Does that help?
That's right. They're pumping liquid oxygen and hydrogen into the tanks of the upper stage.
Corporate schmuckery
they're very
right there.
cold. Liquid hydrogen is minus 253 degrees Celsius. You can see them better here in this image. And oxygen is 180 degrees below zero. And
thank you for letting me know, Nova. I'm not going to switch away from a rocket
and
count that's 2 minutes
here, but
from
sometimes
launch.
you can see a little bit of white smoke coming out. So actually, this is
Well, it's not the best, but I mean, it's there, Chem. It exists,
on the main
dude.
stage, and we have an ignition sequence, don't we, David, which involves it switching on 7
2
seconds.
minutes.
That's
before.
right. That's right. The
Would you
engine
rather go
will
to
be
Florida or
switched off
Texas? I'd
7
rather go where
seconds
the rockets
before
are.
Liftoff. The onboard computer
I
will
don't know,
check
dude.
that everything is working correctly.
There's more stuff to do in Florida,
once that is
but there's
done,
bigger
it will
rockets
send
in
the
Texas
commands to
spoiled, so
open
it's
the
kind of like,
cryogenic arms and to
you know.
ignite the boosters. Once that is done, there is no holding back.
Yep, our rockets will take off. Yes, so people here in the Mission
Rupert,
Control
yeah.
Centre now sort of heading out, because a lot of people like to go onto the balconies to watch
Yeah, that's right,
the
drummer, yep.
launch with their own eyes. So you can see in here in mission control all the
Can you
VIP
see the pad from your room?
seats,
I
all
can,
the,
Gak. Yeah.
Guest seats are empty. The boards are green. We are getting close now to launch.
À tous de DDO, attention pour moins d'une minute.
This is the mission director. Stand by for a call for 1 minute.
Top à 0 moins une minute.
1 minute. 1 minute.
We are 1 minute to launch.
I want you
Best
to run
wishes now
ads.
to all the teams who've been working
Yeah, I
so hard
forgot.
for today. Good luck, everyone.
Bon voyage, CSO3 on
Bon
IM-6.
voyage. How's the workation been? More work, less cation. Yeah, spoiled. I got you. I got you. What's a rocket carrying? CSO-3. It is a military observation satellite, Tyler. This rocket is going to launch north out of French Guiana in South America, out over the Atlantic Ocean, heading towards the North Pole.
À tous de DDO, attention pour le décompte final. 10,
10,
9, 8, 7, 6, 5,
Discovery, go
5,
throttle up.
3, 2,
engine ignition,
allumage de ESR et décollage.
SRB ignition and liftoff. CSO-3 is flying. There we go. Décollage.
La propulsion est
Here's a
nominale.
picture of some clouds.
Pilotage calme.
We have lifted off.
30 seconds in.
6
Stand by for the call for
and
maximum
CSO3
dynamic
have
pressure.
started
That
their
is
journey.
way behind.
He's telling us that the propulsion is normal. We are looking here at our cameras, onboard cameras.
Tous les paramètres à
looking
bord sont
down.
nominaux.
Okay,
Telling
everything
us
looks
that
good.
Everything is going normally. I believe, David, we're looking down here at one of the
Oh,
boosters.
of course they put the,
Yes,
the
that's right. These
information
are the
behind me.
onboard
Hold on, I
cameras.
gotta
We
move.
have a cloudy day
Nominal.
today, so you can see the rocket going through the clouds.
Now I'm over here.
Indeed, we've already broken the sound barrier. We
Pilotage
have.
calme, trajectoire nominale, paramètres à bord nominaux.
He's telling us
Trajectory
that
is
everything's going
good.
according to
All
plan,
parameters
David.
look
we
good.
can hear our rocket coming over the Jupiter Mission Control Center, about 16 kilometers from that pad. It takes time for the noise to get
Okay,
to
everything's
us, the
looking
rumble, as it's
all right
sometimes
here.
known in the jungle.
That's right, and we can feel now the vibrations of the boosters coming up to us 15
propulsion est
kilometers
nominale.
away.
Propulsion is
Indeed,
good.
and it's those boosters which are doing all the work, even though we have switched on the engine on the Vulcan engine on the main stage. The boosters,
Entirely
their
expendable,
job is to
Matt. Yep.
literally boost us away from our
Trajectoire
planet's
nominale,
gravity.
paramètres à bord nominaux.
That's right. It's the boosters are providing more than 85% of the more than 800 tons that we need to take off, and these boosters will burn its 2 times 142 tons of
Pilotage calme.
propellant during a bit more than 2 minutes. And after that,
Everything's
we will
looking good
have
here.
lost
So
about
that
70%
yellow,
of
the yellow line
mass
in the
that
top
we had
right,
at the
guys,
time
is
of
the
liftoff.
actual
That's the name of the
telemetry.
game. The
I
lighter
mean,
we
this
are,
isn't
of
on
course, the
board here,
faster we
sure.
go. Those
Coming
boosters
up on
scheduled
booster
to
separation here.
Propulsion nominale.
detach
Propulsion
in
is
a
good from the
matter
mission
of
director.
seconds.
Discovery,
Seeing
go
our
at throttle up.
images
These
here
cameras are
on the
way
live
behind
cameras.
you.
Séparation des ESR.
Just a few seconds after the
Booster
event, but we have
separation.
confirmation that those have actually separated. As I
Propulsion
said,
nominale.
the images are
Propulsion's
coming
still
to us for
good.
technical reasons, just
See what I mean?
with a very slight delay. And he's telling us that the propulsion
There we go.
is nominal. And
Bye-bye.
there we go. That's what it looks like in space. Those boosters falling away. The trajectory on
Okay.
the right-hand
Alright,
side of our
alright,
screen.
alright.
Trajectoire nominale, paramètres à bord sont nominaux.
Everything's
Everything's
normal.
good.
The green line is the planned trajectory. The cross, indeed, is our actual position
Discovery,
of
go at throttle
our
up.
rocket.
It's
Must
a
be
little bit of a
altitude.
roll component. Okay,
David?
she's
Yes,
settled
we
out.
are close
We're
to
good.
100 kilometers now.
Yeah,
and,
yeah. RT, I gotta
we're
remember
150
that was what it does. It does a
from Kourou,
I think it reorients for the antennas after separation because they have to launch it kind of sideways because of the
second, not
the way they
per
integrate the
second. So
SRBs.
that's
The SRBs are
kind
kind of
speed when we're
diagonal
heading up
on the
towards
vehicle.
getting
So like
to
if the main
8
core is
kilometers
here,
per second.
right,
Look at the
it's
images
better to
on the
launch it
bottom
like
right of your
this,
screen.
right, and
That
then
is
it
the big main
rolls
stage, the tank of fuel at the very
for
front.
the antennas
Sort of
after
pointy
SRB
section,
separation.
if you like,
They do not
is
recover
our
boosters,
fairing
no.
with our satellite inside. It's got a
Propulsion
number of different
nominale.
jobs. It's protecting
Propulsion
the
is
satellite, isn't
good.
Right, it protects the satellite while it's on the ground against dust.
Coming up on separation de cloth. Fairing separation.
The launch itself, the liftoff, because there is a lot of acoustic noise.
What is EJSA?
And
Can anyone
finally,
help?
during the
I'm
atmosphere,
EJSA.
part,
That's
then
me.
it protects it
I'm
against the air
commentating on this
friction
launch
and the
right now,
extreme
bro.
heat that is generated by this friction.
So our satellite nice and comfortable.
Hi, what's up?
Up there in first class, inside the fairing.
Doing good?
Having
Right on, man.
started its journey.
Should be coming up here on fairing
Will
separation.
remain there for
Well,
another few
separation de cloth.
seconds. And of course, as we saw earlier, David, you were explaining it's made in two halves.
That's right, and this is.
That's
the
right,
onboard
KC. I'm going to
camera
switch over
showing
to it
the
when
two
we're done.
halves
That's
of the
inside of the
that
fairing,
is
looking at.
Séparation coiffe.
We have
Separation
confirmation
coiffe.
that the fairing has
The
separated.
cameras are way behind, so
and we'll be
we're going to see
seeing
you're going to see
those
it pop
images on
open
our onboard camera.
like this in a second.
It actually, as it separates,
Wait, is this
David,
live,
it
chat?
It flexes.
Yes,
it's called
it's
the
happening. It is
breathing
live.
mode. It's very specially designed to do that.
Yes, that's right. The breathing mode. Here we go.
There it
We have
is.
The separation.
Separation,
and
the
the breathing
clap.
mode, through the onboard cameras. This breathing mode is this
Trajectoire
movement
nominale.
of the two
Trajectory is
halves
still
that
good.
happens,
Oh,
due
this
to
is
the
space.
forces
I'm in
of
space.
No, we
the
get to the top to blow the
paratechnic
river.
Separation and then the ejection forces and the flexibility of the structure.
Looking back down at our planet now, you can see that thin blue line,
La propulsion est nominale.
Propulsion is
the
good.
atmosphere of our Earth. He's telling us that the propulsion's normal, everything's going according to plan. So we're burning the main stage. It's a great big tank of fuel.
If live, does it
David,
really
tell us
take an
a little
hour to
bit
get to the
about
moon?
that.
Yes,
No,
so the main
Semi.
Discovery,
stage is
go at throttle up.
This is a different
stage is
mission.
32 meters,
There's so much stuff happening
tall
in
and
space.
about
The
5
moon
meters
lander's already
diameter.
out there. It was
It
launched
weighs
a week ago.
23 tons,
Um,
burns,
This is a different
154
rocket launch.
tons of
There's so much
cryogenic
stuff that I
propellant
don't really have.
and 2
It's tough to like
tanks
name
and
the
a hydrogen
stream
tank in
for like moon landings and stuff, so I combined it. This CSO3 mission that you're seeing on the screen right now is not. This is not the one that's going to the moon. This is a French military observation satellite that's launching right now. The moon landing stream, the Intuitive Machines IM-2 landing, the Athena, I believe, is live right now, but that landing's going to happen in a little bit. So when we get to Extinction Volcane, and then a little bit after that, that's main engine cutoff. I'll switch over.
in order to protect it from the heat coming from the boosters. And this will burn for over 7 minutes, increasing speed and altitude.
Hey, you're
Discovery,
71 months
go at
resub.
throttle up.
Thank you.
Separating each section
Knocked
of
us out
the
of 7
rocket
months resub in there as
looks
well. Thank you very
simple,
much.
but of
Minion,
course
89 as well.
a lot
That's
is
one with
actually happening up
114.
there, and we're getting closer
you.
now to the next main event, which will be cut off of that main engine.
Yeah, Vasi, it's a good day
Yes,
for
that's right.
space.
It's the
Good day for
guidance
space.
algorithm that's on the
Pilotage
onboard
calme.
computer.
I
that
think
will
it'll go.
detect that we
Chicken
have
head, I hope
reached
it will.
the right orbit for separation. And then it will send the shutdown command to the Vulcan engine. After that, we will have a pyrotechnic separation
French
between
invader.
the two stages.
Merci.
And a set of springs that will push away the two stages. And we should be able to see it on the onboard cameras.
You can see on the bottom
Pilotage
right is you can see our satellite CSO3
Yeah,
attached to the front of the rocket.
The
top of
landing
the
should be
rocket.
happening
Nomino.
soon. Yeah. About an
Coming
hour
close
from
now
now,
to
give or
the
take.
next event, we call it MECO.
Good
main
day for
engine
space and day for the
cutoff.
world, as is tradition. What's up, Arnold? Stand by for the call for Extinction Volcane.
Extinction Vulcain.
Oh,
Confirmation
very nice.
that the engine has switched off.
Should get a separation here.
Séparation LLPM.
And we have confirmation that the main
Stay-
stage
core stage-
Ainsi. Fin de mission sauvegarde.
has separated, and the upper stage has
There we go.
switched its
There's the separated
engine on, and
separator.
that's what it looks like.
And then the
up
Vinci
there
engine
in
is ignited.
space with our onboard
Whoa!
cameras, that great big
Hey! Hey! All right.
It's burnt its fuel. It's falling back down to
Purge
Earth.
down on the core
So,
stage there.
David,
Dude,
the
what a
stage is taking
shot.
wheel. It's a little bit like
Oh,
a-
that's
This is
not
space.
bad at
I'm in space.
all.
'Cause its job is to jump off its
Yo,
bus.
that's pretty good.
Passengers in space
Decent with a
today, we just
5.
have
Thanks,
one
man.
one passenger. And
That was
we've
pretty
got
good.
a new engine
That was
for
pretty
the
good.
upper
We saw a
stage. It's
purge
called
down
the
on the first
engine.
stage after they separated it.
Yes, the Vinci engine
Here,
is
back
one of
this up. I'll show you.
Oh, with our
Watch,
onboard
watch
cameras,
the
that
engine. So the
great
engine,
big
as you see a plume come out of the engine, that's
of
yeah.
propellant
No, is
that's
that
burnt
Sergeant?
its
Yeah, no.
fuel, it's falling
It's
back down
most
to Earth.
engines cut
So,
off.
David, the upper
That's pretty
stage is
good,
taking
man.
the
That's a
wheel. It's
pretty
little
good
bit like
shot.
fancy orbital
All
taxi
right.
driver, 'cause
It's a rocket that has a
Das is here.
cryogenic engine with this reignition capability. For the mission today,
That's
we
pretty
will
good,
use
man.
the
That was
engine
pretty cool.
twice to deliver
Great visual.
CSO3 to its orbit.
Propulsion nominale.
And after that, we will
Is
use
this Starlink?
a third burn
No,
of the engine.
well,
to
the Starlink
deorbit
booster didn't
the
land
upper
yet.
stage.
And we had the range operations manager just back there announce that
Oh,
we've
no.
switched on something called the APU, the auxiliary propulsion
Yes, they
unit. It's a
understood
new
the
device that
assignment.
we've
Yeah,
got
right, yeah.
on the
Out
upper
in
stage.
space.
It
Yep,
performs
yep,
a
yep.
number of critical functions to
Trajectoire
enhance the
nominale, paramètres à bord
versatility
nominaux.
of
Trajectory is
Ariane 6.
good.
Everything's going normally. We'll talk a bit
Mission
more
is
about
going
that,
good.
David, later in the program. So do stay tuned. But just before we do, a shout
Yeah,
out for
the second stage is
Franco-German
going to take a
cooperation on
dip,
the upper
guys.
stage.
That's
Yes,
fine.
the upper
That's
stage,
totally
which is
normal.
designed and built
Why purge the
by,
engine after separation?
Ariane Bremen
Isn't
in
it being
Germany
disposed
with
of?
an
It's
engine
passivation,
designed in
Nader,
Vermont in
mostly.
France.
Propulsion nominale.
And the
You don't
whole
need that
thing
thing
was
blowing up.
tested during the development of the
Acquisition de la
launcher in
télémesure par la
Lampolshausen
station de Bermude.
in
They have an acquisition of
a
signal,
test bench designed by the
telemetry through
German
Bermuda.
Space Agency.
And we picked up the
nominale.
signal
Trajectory
in
is still good.
Bermuda. So once we release CSO3, this French Space Agency will take on their satellite.
Le CNES, agence spatiale française, assure par délégation de la direction générale
here's
de
your
l'armement
promo
la
video
maîtrise d'ouvrage
from
du projet
CNES.
CSO. Cela
Propulsion
va de la
nominale.
conception du système satellite
Yeah,
jusqu'à sa mise en orbite
those,
et son exploitation
That
opérationnelle
separation video
pendant
was
toute sa
sweet.
durée.
Or not video, the separation
nominaux.
Compétences
view
métiers
was pretty
pointues
awesome.
et un savoir-faire reconnu depuis 35 ans. C'est au CNES que sont
I didn't
opérés
hear anything about
quotidiennement les
APU
satellites
start.
afin
I
de
may have
programmer
muted
les
it,
prises
though.
de vue commandées
We'll
par
see.
la direction du renseignement militaire.
Look at this radar dish.
Le CNES vient de recevoir les listes de programmation à envoyer au satellite CSO. L'équipe mission a préparé les automatismes permettant de transformer les listes reçues en ordre élémentaire pour chacun des satellites. Les
Madame
ingénieurs
les
mission
tailleurs.
surveillent le
Oh,
bon
no.
déroulement des activités pour
Everything
intervenir
looks
en
good,
cas
another
de
good call.
problème et ainsi maintenir un très haut niveau de disponibilité du système pour les utilisateurs. Les télécommandes sont prêtes. Pendant ce temps, l'équipe bord veille au grain. Son rôle, assurer la bonne santé des satellites. Elle réalise des activités permettant d'anticiper les problèmes sur les satellites afin de garantir leur
So,
fonctionnement et une disponibilité.
Remember, everybody, the top right corner up here, this is real telemetry. That is a live onboard, but their onboards are like 30 seconds behind the calls. This right here is the real telemetry in real time. Basically, that circle right there represents your nominal track. That's the ground track. Or, well, basically your ascent corridor. And the X is the telemetry from the rocket. So it's basically, as long as the X stays inside of the circle, everything is looking good. Yeah, sometimes you get some deviation here. But yeah, that's what they mean by nominal. You're within a nominal range. As long as the center of the X stays inside of that circle, you're good to go. If the X leaves the circle, you got a big problem. That usually means the rocket is not rocketing how you wanted it to.
Permet d'intervenir au plus vite dès qu'un incident est détecté. La moindre défaillance est traquée et corrigée en un temps record.
Yeah, Bronze, that's right. Ariane 5 would play B-roll footage during separation because they didn't have onboards. That was a live onboard, which was really cool.
Du réseau corps, les antennes prennent le relais. C'est le point névralgique à partir duquel elles sont pilotées pour émettre des télécommandes et recevoir les télémesures. La station Dos Agalicius est désormais
Yeah, Aqua, that
connectée
happens.
au satellite
Centaur does that.
CSO
The shuttle did that too,
visibilité.
for what it's worth. This kind of
Au CPCC,
throw it up in the
maintenant
air
que le
and
satellite est connecté
it
et
kind of sinks
positionné
back
sur son
down.
orbite mission, le
Doing
contrôleur
that gives you
supervise le bon
basically
déroulement
if
des
you
dernières
add more power to the
activités pour
first
se dérouler
stage or
comme
more
prévu.
energy to the
Des
first
télécommandes
stage, you can afford to make the second stage a little more efficient at the behest of thrust. So you get these low energy orbital insertions. The shuttle basically did this every time. The SRBs yeeted that thing way up in the air, and then it kind of fell back down. But before it fell back down to Earth, right, the three main engines on the shuttle would circularize. Centaur does the same thing. Yeah, it's just your trade-offs, right? You add more kick to your first stage, you can make your second stage more efficient, and if your second stage is more efficient at the behest of thrust, right, you can make a more efficient rocket that way. Yeah, the dip like that, that's totally normal. If you guys notice, like if you're looking at the telemetry, like the thing went high up in the air and now it's coming back down. Right, but it's going to accelerate before it comes back down all the re-enters.
14 minutes into the flight, the rocket talks to us as it flies over. It communicates with the tracking stations. They collect the data and they send it here to what we call the CVI, or the Quick Look Telemetry.
When in doubt, add more boosters. Nice try,
The
Jeb.
Guiana Space Center. There they are, bottom right-hand side. He's telling us
Everything's
that
looking
going
good.
Normally, the range operations manager.
So the speed that you're looking for is about 7,600 meters a second, or 7.6 kilometers a second. That's orbital velocity. Because this is going to go.
And they compare this live data from the rocket.
It's going to go a little bit further than that. They should be right around 7,600. These types of satellites usually go to sun synchronous, and the sun synchronous style orbits are highly inclined retrograde orbits. With their APs usually around 500 to 600 kilometers.
Moi, je suis
Everything looks good.
campagne Operation Manager, donc le chef des opérations de lancement sur la campagne VA263. Fred est mon député sur cette campagne, mais ça n'a pas toujours été le cas.
Sur le premier vol Ariane 6, qui était le vol inaugural, qu'on appelait aussi FM1, j'étais Elcom sur la campagne et Nicolas était mon député.
Ce qu'il faut voir, c'est qu'on va échanger nos fonctions pendant tout le début de la phase IOC, l'Intermediate Operational Capability, de manière à ce que chaque fois l'un soit en titre et l'autre soit en deputy, et fasse en sorte qu'on profite de la
That's
campagne
right,
en cours
Lumbo.
pour déjà
Yeah,
préparer
this is
la
on
déjà
purpose though,
préparer les
right? Like they do this on purpose. They purposely make the second stage lower thrust, but they make it more efficient.
Voilà, donc c'est ça l'enjeu de cette phase un peu particulière qui est le début de la phase d'exploitation.
L'idée en fait d'être deux aussi sur Sénat, c'est des formes de continuité, du pilotage,
Everything looks good.
l'amélioration de nos process de pilotage, de notre organisation, mais aussi de notre montée en compétences et en maturité technique. Donc on a besoin aussi de ça, de cette continuité sur chaque vol, parce que le système en fait il est jeune aujourd'hui, donc on est en train de le faire grandir et il est évolutif et on a besoin d'être à deux pour assurer cette continuité de manière efficace.
That's right, Oladi. Yep.
Mon métier de directeur de mission satellite consiste à vérifier au préalable que le satellite est compatible du lanceur, donc des environnements à la fois mécaniques, électroniques, électromagnétiques,
They have acquisition of signal at Gatineau.
acoustiques, un large panel de métiers et de technicité pour valider la bonne interface et compatibilité du satellite avec le lanceur. Ici en Guyane, mon rôle de directeur de mission satellite consiste avec Arianespace à piloter la campagne de lancement du satellite jusqu'à la chronologie finale et la mise à poste par le lanceur.
Je travaille sur le projet depuis 2006. J'ai commencé par le pilotage des satellites. Ensuite, je me suis occupée
Okay,
de
we're past 7 kilometers a second. Shouldn't be much longer now before
de l'instrument, donc de la charge utile fabriquée par
second
Thales
stage engine
Alenia
cutoff
Space.
1,
Et
SECO
depuis
1,
2021,
or
je
first
suis
extinction
responsable
Vinci.
de l'ensemble du programme pour Airbus. Sur un projet de cette envergure, des centaines de personnes ont contribué, de la phase de conception
Gatineau.
à la
Oui.
phase de développement,
Oui, Gatineau.
puis de fabrication et finalement de tests, et tout ça dans nos locaux à Toulouse.
Le développement de l'instrument et de ses équipements a été réalisé par des équipes Thales Alenia Space très expérimentées, pour beaucoup, elles ont déjà travaillé sur Helios 1, Helios
The
2,
APU didn't
Pléiades.
relight
Toutes
last
les
time, spoiled.
activités sont réalisées sur les sites de Thales Alenia Space, de Cannes,
7.3 kilometers a
Toulouse,
second, almost there.
Aix-en-Provence pour Thales CESO. Nous avons
What's the general
actuellement une
longitude of
équipe
ascending
qui est
node
présente
for
sur le
these types
site
of
du
SSO
CNES
launches? I'd
Toulouse
assume it's very
pour
classified. It
participer
depends.
à la
Yeah,
mise en poste
Angie, I have no
et
idea.
aller jusqu'à
la aux premières prises de vue visibles et
They'll
infrarouges de notre instrument.
they'll fine tune the
Pour
orbit
Aerospace,
in
je suis
for where they
responsable
want,
production
but a
des
land on
adaptateurs.
this,
C'est
I
une
have
pièce
no idea.
mécanique
I
qui
know
sert
it's sun synchronous
d'interface
because it's an
entre le
Earth
satellite
observation
et le
satellite, and it
lanceur.
launched
Mon
north
travail
out of
consiste aussi à
Kourou.
apporter une expertise technique lors des
And
opérations
looking at the
d'intégration du
trajectory
satellite
here,
sur
you're not
l'adaptateur et sur
getting
le lanceur, et ce, dans
Propulsion
le but de
nominale.
garantir
initial
la bonne
insertion is
intégration du
360,
satellite
so
sur le
yeah, they
lanceur, son aptitude de
oh,
vol,
hold up,
jusqu'à sa
coming up
séparation.
on
Ce qui est passionnant
engine
dans mon
cutoff
métier, c'est
here.
que je joue en fait le rôle d'adaptateur
7.6,
entre le monde du lanceur Ariane
7.61,
et le monde
62.
du
Nice.
satellite avec notre client CNES et le constructeur du satellite
Yeah,
Airbus.
okay, so
Avec
we're
mes collègues
little
d'Ariane
above
Espace,
like
notre travail est de faire rencontrer
parking
ces deux
orbit
mondes
velocity. Yeah,
pour garantir le
this is
succès
sun
de mission.
synchronous all day. 7.71.
Incredible. David, they're your colleagues. It must
Colleagues and customers both working hand in hand to make this
What
a
is the
success.
Kourou distance?
Indeed, I
Kourou
think
distance
everyone
to
can
what,
feel very
Vidojo?
proud.
Oh, that's
Coming up
downrange.
to the
Downrange. How
next
far it
major
is away
event,
from the
that
launch site.
will be the switching off of the Vinci engine. That's
Okay,
it
so
looks
they're
like it's
orbital
burning at the
right now,
moment,
guys. So now they're
and
pushing
has
up what's
about
called the
5
apogee. They're
seconds
pushing
left on the
apogee
burn.
up.
Première extinction Vinci.
7.93.
Confirmation
Yeah,
there
this is
that
sun synchronous
the
all
engine
day.
has indeed switched off.
This is an SSO orbit.
So, the first major
there we
step
go. That's
Discovery,
first
go at throttle up.
or second stage engine cutoff 1. They shut the Vinci engine off, and now they're going to be safing. That's what that. If you see some smoke kind of pulsing out from the onboard camera there on the right, they're basically safing it for another insertion or another engine ignition here. But that engine ignition is going to be a little ways away. So 7.93 kilometers a second insertion. So velocity is reading 7,900 meters a second at 350 kilometers. That's sun synchronous, meaning their apogee is right around 400 to 500 kilometers with that type of orbital velocity at low point in your orbit. Because if you look over in the top right, they're kind of in the middle of a dip. They're like in a trough almost, right? So that means that's perigee. That's the lowest point of the orbit. And now they're only going up from here. So from here, their altitude will go up and their speed will go down.
Discovery, go
meaning
at
you're
throttle up.
coasting to apogee, which is the highest point in your orbit, right? 7.93 at perigee, which is the fastest point, indicates that that's not that far off from like 7,600, which is what you need to get circular at this altitude. So I would guess final insertion is probably about 550 kilometers. 550 kilometers circular. And we know they're doing multiple burns here. So, yeah, this is sun synchronous, but NG, I have no idea what the LAN is on this one. I couldn't tell you. I'm sure that could be extrapolated, but I'm not doing that math in real time. I'm sure we could figure it out.
Orbit.
He's telling us that the propulsion's normal, everything's going normally according to plan.
Okay. All right, guys. Well, that was a good launch for Ariane 6. CSO-3 is on its way. It will do more coasting burns here in a second. It's going to coast for a little while, and then it will do a couple of different burns. But I'm going to switch over to Intuitive Machines here now. All right. Let's just go over here. Just got to remove some windows. We're going to switch to IM-2. Yep. Okay, move that over there. We do, on a quick side note, have a soft roadblock at Boca. Soft roadblocks up, Das. I got a nodders from Das. All right, cool. So that's boding well for launch where I am. I'm in Texas. Are you back in Boca? Yeah, I've been here for a long time. Weeks. We've been here for a minute. We're waiting, just jonesing for this thing to launch. But, yeah, physics had some other plans, you know. I don't know, Nova. Anyway, we'll switch over to the NASA cast now. So we'll flip that. We're flipping over to Intuitive Machines. Intuitive Machines is a private company that is contracted to land a mission on the moon with their with their Nova C lander. The Nova C lander. This is the second one that's going to land out there, and we are sitting at 42 minutes out from a landing here. So I'm gonna unmute this and let's listen to some stuff here.
Because of the moon's tilt, that the craters near the pole are permanently shadowed. They never see the sun, so they're extremely cold. And we
Going
believe
back
that
over here.
water
No,
and
I'm over
other
here.
volatiles could build up inside those craters and in the polar region, and that represents a resource for future robotic and human exploration. And also, the poles are sort of lunar incognita in that they've been relatively underexplored. If you think back to the Apollo era of exploration, that was all sort of equatorial.
Also,
so,
Intuitive Machines has
there's
one of the
still
most
a lot
baller
to
control
learn
rooms
about
I've ever
them.
seen.
Absolutely. And so can you tell us then a little bit then what's different then from both the landing locations of IM-1 and IM-2, even though they're in a similar area?
I would say there are more similarities than differences between the two landing sites. The poles are a challenging location in that when you look at the moon, you have sort of the dark regions that you see, which in Latin are the seas and the lakes. They're relatively flat
I'll
terrain.
move back over
But we
here.
want to explore the poles. The poles are what they called highland terrain, more rugged, low sun angle, which
So you
makes
can
them
see the guy.
challenging. And so IM-1 landed about 80 degrees south. It's also the location that the NASA with Artemis wants to send crew. So we're gradually working our way towards the poles. We're about twice as close to the pole
Ruinous,
as
it does
IM-2,
look like that. Many
about
Boston
85
spies
degrees
died
south,
to
about
bring us this
160
information.
kilometers,
Admiral
100
Akbar,
miles
please.
away from the South Pole.
And now, you briefly touched on
You need the
it,
green screen, it would
but
fit
can you
right in.
discuss some
Yeah, I
more
don't
the
have one
challenges
here.
of
I couldn't fit it in my
landing
luggage.
the South Pole?
Yeah, so I think when the team picks a landing site, there are really three parts to that. The first
That's
part,
right,
the
Quag.
most important part, is it has
Yep.
to be a safe landing
So Intuitive
site.
Machines had their IM-1 lander, Odysseus. They went to land about 6 months ago, and the thing tipped over. But it tipped over on landing. But that is there's a lot more to that story. So their optical landing system, right? They had the lens cap on their optical landing system because the range made them when they put the lander, like when the lander was at, its launch site, the range made them put the lens caps back on to their tracking to their optical trackers, right? And because the range made them do it willy-nilly, they forgot to take them off. They basically had an integration plan that said, take the lens cap off and then bring it to the launch site. And the range said, no cameras. Don't do that. So they made them put the caps back on their optical rangefinders. When I say optical rangefinders, I mean a camera. How this thing lands is it's using a range-finding system. Basically a camera that's going to get you your distance to the ground, for instance. That's kind of important if you're making a lander. So what this lot did right here, what these guys did, not them, what they did was basically hack into their own spacecraft. And obviously you're not going to take the lens cap off on a spacecraft that's coasting out to the moon, right? Obviously that's not going to happen. So what they did was they realized that NASA had an optical tracking experiment on their first lander as a secondary mission, right? NASA was like, hey, let's put this on here and we'll test it, So what Intuitive Machines did was hack into their own spacecraft and rewrite the code so it would use NASA's rangefinders to land. And it did, and it worked. Now, people could say, oh, it tipped over, it didn't work. No, it worked. It's intact on the lunar surface, except it broke a leg because they hot-wired the spacecraft to get there with a range-finding system that, honestly, NASA's range-finding system was at the bottom of the lander, and their range-finding system was at the top. And I think that difference right there is the reason why it landed and tipped over, because that's about a meter difference. So if it thinks it's a meter below where it is, it's going to land too hard and snap the leg. But they did land it. And they hacked into their own dang spacecraft. That's what the Nova C lander looks like. See what I mean? There's about a meter difference between the bottom and the top. They hacked into their own spacecraft and made the payload and hotwired a payload to their guidance system on the last mission. And that's why it tipped over. The lens caps, I assure you, are definitely off this time, so they don't have to do that. So, yeah, they're gonna try again, and I have a good feeling about this. We'll see what happens. Yeah, it's one of the it's a real like Apollo 13 story. They hacked into their own dang spaceship and hotwired it to a payload while it was coasting out to the moon. It's pretty righteous. I really like Intuitive Machines. I became a really big fan of them after that. Yeah, Virtual, this is a tiny little lander. Oh, there it is. Here, look.
Similar to the reflectors on your bike that enable precision laser ranging, which is a measurement of the distance between orbiting or landing spacecraft to that reflector that we have on Athena. LRA is mounted on Athena's top deck, so when a laser hits it, it reflects light back to the orbiting spacecraft. And LRA is a non-powered or passive instrument that's intended to function as a permanent location marker for decades on the moon.
Ah, those are lunar rangefinders. They basically what you can do is you can beam a laser to that reflector and it'll shoot back, and you can figure out the distance based off of the light reflection. Yeah, dude. The IM-1 mission was so good. I'm really hoping they nail this time. Did they strengthen the legs at all? I don't think so, goalie. There's no need to. Why would you strengthen the legs when... Why? Like, wait, I'm not sure why you would do that. The guidance system was the problem, not the legs. The legs cracked because they hotwired the thing from 200,000 miles away to work with a payload range finding system.
Commercial payloads flying alongside NASA's Prime 1 drill suite and laser retro reflector array.
That includes commercial payloads.
This thing has a little lunar rover on it. Believe it or not, there's a little rover that can deploy from a little garage that kind of like falls down onto the side. There's a bunch of cool stuff on this one.
Just in a second.
Absolutely. Some additional payloads on board Athena are largely driven by NASA's Space Technology Mission Directorate.
So over here, that guy sitting at the table, that's I'm pretty sure that's Steve Altimus. He's the CEO of Intuitive Machines. And then there's the lead engineer. That's Dr. Tim Crane right there. These two, they're really cool. They in the press conference, I really appreciate what Steve Altimus said after the IM-1 mission. He's like, look, we forgot to take the caps off. That's on us. That will not happen again. I really appreciate Intuitive Machines because him and Tim Crane took accountability for their actions. Oh yeah, also there's a hopper on this, by the way. Yeah. There's a hopper payload on this thing. Just thought I'd let you know. They took accountability for the IM-1 mission. You know, they hacked into their spacecraft, right? Got it to land on a hot-wired guidance system, right? And still we're like, no, we screwed up. That won't happen again. We will not make that same mistake twice, which is pretty cool. I really appreciate them taking ownership of that failure, even though hot wiring your spaceship to work when it's on the way out to the moon and actually getting it relatively intact on the surface is an amazing feat. They still were like, no, we screwed up. That's not going to happen again. And I appreciate the accountability. That's what you need to do when you run a space program like this. Guys, you know, we get kind of spoiled by low Earth orbit, right? We get kind of spoiled by it. You know, like we see rockets launch all the time. We just watch an Ariane rocket just dump a huge payload that's the size of a truck into space. Yeah, no problem. Once you get past low Earth orbit, the difficulty scales exponentially. And the only way to really make this work is to take accountability and just get it done. Like you have to run your program that way. If you don't run your program that way, you're going to get into some really bad problems. You got to run it like Apollo 13. They took accountability and they got their astronauts home. Straight up. That's the kind of attitude you need to have. And I really appreciate Steve and Tim for that. That's really, really cool. It really made me happy. So I'm really hoping they stick this landing.
So with the tipping points,
industry, the companies we're working with, put contributions in. They have internal research funds in development, and then the government puts money in. So we're true partners in
Yeah, they wear
creating these
vests because of Gene
capabilities.
Kranz. That's
Now,
cool, Ordon.
specifically
Yeah.
on IM-2, why did NASA decide to invest on Intuitive
They're landing a
Machines'
lander with a lander.
Micronova Hopper,
Yes.
or Grace, and then also the Nokia Lunar Surface Communication System?
So I'm glad you asked.
When was the last time
so we have something called the Lunar
the U.S.
Surface
landed on the moon
Innovation
right side
Initiative,
up?
and it was started in about 2019,
last week?
shortly after Artemis. The whole idea there was, in order to do anything on the moon, you're going to have a set of capabilities or technologies that everyone is going to need.
Let me get the YouTube
Just your
thing
basic
off.
infrastructure, if you will. So things like power and surviving, the dust and the environment you're in. But two of the key areas that come up over and over
Last
again,
week,
of course,
dude.
Are autonomy
Firefly
and
landed the
robotics
Blue
and
Ghost
ability
1
to be
mission.
able to get around. We all
Ghost
know that
Riders
there
in the
are
sky, and it
places
was
on
an
the moon that
amazing
are
landing.
more
If you guys
treacherous
haven't
than
seen that
others, it's a pretty
footage,
rough
I'll show you after
environment.
after
So we
the
have
IM-2
permanently
mission.
shadowed
It is
regions, which you've heard
excellent.
about earlier today that we want to get into. The Hopper can do that, right, and get that data, show us what's in there. That's where we think we might have some water or ice. For the communications.
So over here, you have your relative navigation camera, and I'm not sure what HRN means, but this is terrain relative navigation. This is, so like I said, this lander has an optical, it basically has cameras pushing, like looking down. Like you could see behind me right there. They cut the camera. You can see behind me right there. It has, I'm going to move next time here. I'm just moving all over the place here. Let's just do that. So I'm right here in the center. Basically, relative navigation is a camera that's basically been trained on what to look for, right? So the relative navigation system is basically a downward-facing camera, and the computer looks for a good landing site in a very similar way to, like, if you were like a helicopter pilot and you're flying around and you're like, oh, that's a nice place to land. Let's go land over there, and you go land your helicopter in an open field as opposed to landing it in a forest, right? The relative navigation systems use cameras to actually look for a flat spot, which is super, 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 super cool. Hot Wing Research Node, human rated number, hazard relative navigation. I believe Rocket Guy, thank you. It's time to wake up. So hazard relative navigation. So this thing has a couple of cameras that are actually looking in different directions to make sure that the computers know to land this thing in a flat spot, which is super cool. That's actually the part that they left the lens cap on last time. So yeah, to see that they have the cameras up on their UI is actually super cool. I guarantee you that is on purpose. Help! Rapid nosedive. I really hope that's not what that stands for, Kyron. That would be really, that would not be good. All right.
Tony and Nikki, here's a deeper look into how the Nokia tipping point will work and the benefits for future missions.
On Earth, a cellular network has many components. Base stations,
He's the rocket guy.
radio units, and a core network that manages the connection between users and the network. Nokia's technology miniaturizes and integrates all of these components into a single network in a box.
For the Nokia from Finland. Yeah, very nice.
This is Nokia Bell Labs network in a box that you can hold in your hands. It contains every single component that make up a 4G LTE network. Scaled down to this size, weight, and power, we could install it onto the Intuitive Machines Nova Sea lander, along with the specially designed antennas. Every gram that we send.
Hey EJ,
Hello.
Just wanted to say thank you for humoring my fiance and recording a birthday message for me last weekend. It was an awesome surprise, from Starbase no less. Great coverage as always, go Starship.
Yeah, you like that? It's pretty good, right? My pleasure, man. Happy birthday. There you go. Thanks for the tenor. Appreciate it, man.
For the
It was
mission
her
to
idea.
succeed,
Just
this
saying.
network
It's her
must be
idea. I had
fully
nothing to do with it.
autonomous.
I just
It
in
must
front of the
deploy
camera,
and
man.
configure itself once on the lunar surface. As the lunar rover goes about conducting experiments,
And you got a cameo from
and the
Mr.
hopper
Yak.
goes deep within a crater, the network must also constantly make adjustments to ensure it maintains connectivity.
This is an uncrewed mission. There will be no human technician to tweak or repair the network if something goes wrong. Achieving that level of autonomy
Mr. Yax.
was a monumental task
Do we
to
have
undertake.
Mr. Yax?
Working with NASA's Space Technology Mission Directorate, Nokia plans to test the first cellular network on the moon. Success will have implications far beyond this important mission.
In addition to the NASA payloads and tipping point initiatives, Lunar Outpost has another mission objective. Not only will the Lunar Outpost carry the Nokia tipping point demonstration, it will also collect lunar regolith, also known as lunar soil. Lunar Outpost and iSpace have contracts through NASA's Space Operations Mission Directorate for regolith collection. When
Funny,
completed, the
doesn't
companies
sound
will provide
Finnish.
imagery and location data of the collected material and transfer ownership to NASA.
Now, the purpose of this effort is to show that transfer of
Yeah,
ownership
work.
from
There you
private
go.
to public. Lunar Outpost map rover will be on IM-2. This
look,
rover
look.
will also carry the Nokia tipping point demo we just mentioned and traverse the moon. And the company's lunar surface communications system, that's from Nokia, will demonstrate proximity communications between Athena, Lunar Outpost rover,
Look,
and
it's
the
going to
hopper.
deploy a little
The
baby
Lunar
rover.
Outpost map rover aboard the IM-2 mission will also carry
at
a
the little
technology
baby
from
rover.
the MIT Media Lab Space Exploration Initiative called Astro-Ant, which was tested
Look, it's
through
a little baby.
STMD's Flight Opportunities program. To change the pace of space, the Science Technology Mission
Little
Directorate's
garage. Yeah,
Flight
Ruber, you think I was
Opportunities
kidding?
program works with industry
it's a little
flight
baby
providers
garage.
to rapidly demonstrate promising technologies in
baby
reduced
garage.
gravity and other relevant environments.
And Leah, we're just about 12 minutes from Athena starting her final approach to the lunar surface.
Here we go.
And things are moving forward as going into an intense
It's not that bad, Jack.
11-minute main engine
Couple
firing
of seconds.
towards the lunar surface. And to this point, Athena has traveled over 700,000 kilometers up on the Viz over 8 days for this final, very risky maneuver.
Yeah, risky
What
is
is the
right.
timer
It's no
for?
secret that
Lunar
landing,
landing,
on the moon
baby.
is challenging. Countries around the world have attempted this incredible feat, with some being
Discovery,
successful
go at
and
throttle
some
up.
not. Of course, the United States has landed on the moon many times, most notably
Yeah, we
during
have.
the Apollo program. But today we're looking for the third landing by a U.S. commercial company enabled under NASA's CLPS initiative. Ahead of these important milestones, let's discuss the challenges of landing on the
Hey,
moon
Galactic,
through
43-month
CLPS.
resub.
Take a
Thank
look.
you. 25 minutes from the landing. Look, it's a little
Landing on
garage.
the moon is hard. We're going back. Under this Artemis
Please?
program, we're going
Please
to be
go back.
sending humans to the moon
Yeah.
for the first time
Yeah, you should
since
do that.
Apollo. So
Yeah,
ahead
do that.
of humans, we want to get up as much science exploration and technology experiments as possible.
Yeah,
so CLPS
see that?
starts
We should do
facilitating
this.
a lot of the early science, the things we want to learn before we even send humans. CLPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA
Jack, what's going
controls
on, buddy?
the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is
Oh,
a
not that
delivery
one, though.
service, akin to a
Not that one.
delivery
You see
service
that?
you
Not
have
that one.
here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest
Why
levels of
would
the
you do
agency's
that, Kelly?
leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some
That's
failures.
correct, Booker,
Some
yeah.
of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely.
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing
Prepare to
to take more
fast
shots
forward.
on goal.
Preparing to
We
fast
aren't
forward.
risking human lives. And in the
Fast
big
forwarding,
picture,
sir.
If we're flying missions at 1/10 of the cost of a NASA mission and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's
I'll
not a
have
single
to
one of these
look at the
companies that's willing to
context,
bet their mission on a
H-Town.
coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize.
There we go.
is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
The clock at the top saying G.
We are coming up on just about
I don't know what the
22
G stands
minutes
for.
from Athena's planned lunar
But
landing
that's
attempt.
that's their time.
Let's take a live look into Nova Control. Josh, can you tell us what's going on right now
Yeah,
inside
ground
your Mission Control
maybe.
Center?
Well, flight
Yeah,
controllers
that's a
are
good
all
guess, NORAD.
monitoring Athena's flight data in near real time. That means Athena is sending data from nearly 250,000 miles away to ground stations contracted by Intuitive Machines across the globe and into Nova Control. The mission director and landing system
Great.
experts are looking at a screen called the deorbit
Gouda.
descent
I want
and
it to.
landing.
I mean, the
or
moon is
DDL
made out of
screen.
cheese, so
It's used primarily while
Guesstimation.
Athena orbits the moon through to landing. That same data flow is being interpreted through a video game engine.
They're
to
landing at
create
the.
what we call the viz that you see on your screen.
They're
right
landing
now.
a.
Well, we have made some improvements
it's
to
South
increase
Pole.
the fidelity and reliability
Gucci,
of the viz.
yep. Gucci
We
minus
expect
21
to keep
minutes.
it up for you during the landing, although the last few seconds may be an estimation of what's happening, as Athena may lose communications contact, particularly when she pitches over right before vertical descent.
All right,
Right now, looking at the viz, it shows Athena approximately 15 kilometers above the lunar surface, so we're getting close. Now, when the lander
Okay,
makes
Nova.
it down to about 10 kilometers, we expect Athena to continuously fire her main engine, throttling down until softly landing on the lunar surface.
And Leah, that final burn is called powered descent initiation, or
PDI.
PDI. Athena must slow
Good to
down
hear
by
those
about
words on a NASA
1,800
cast
meters
again.
per second, which doesn't mean too much until we typed it
We
into
heard it
Google.
last
That's
week.
about
Whatever.
4,000 miles per hour. That's because she's approaching the
good.
landing site coming
Please,
down
more
from
PDI,
orbit, so she has
please.
a lot of lateral speed. You can think of PDI like hitting the brakes on your car in order to make a safe turn. But in Athena's case, that turn is moving into a vertical upright position to start descending down to the lunar
This is live.
surface.
Yeah,
PDI
Wolfpack,
should
I'm
be
here.
starting here just in about 6 minutes, I believe. Leah?
The teams here in Nova Control have been working diligently over the past 7-8 days to take us this far. Now, again, only 15 kilometers above the lunar surface.
We're doing it
We're
live.
following the countdown to
10
Athena's
miles off the
landing
surface.
attempt. But for now, we're heading back over to Tony Hadamia, who is standing by with NASA's acting administrator, Janet Petro.
Yeah, I got you, Wolf.
Thanks, Leah. It's always an honor to be joined by NASA leadership, and joining us now is Acting Administrator Janet Petro.
Do it live,
Janet,
Booms.
we're getting
Do it live.
20 minutes until landing. How are you feeling?
I'm feeling super
20 minutes.
excited. You know, got a little nervous, fingers crossed, toes crossed, but looking
crossed?
forward to it.
You can do that?
Absolutely. I have everything crossed too. You know, can you tell us a little bit more about the challenges of landing on the moon, especially for these uncrewed robotic spacecraft?
So Booger, Athena has a lot of different scientific payloads. Two of the big ones, actually, I'll mention three. So one of them, there's a rover on board that this thing is going to deploy, and the rover's going to rove around and do rover things. The second one is that there is a hopper on it as well. So if you look at the patch, right, there's the rover right there, and then there's the hopper. See? They're going to deploy a NASA payload that hops around on the lunar surface. Yeah, 2 rovers even. Yeah, exactly. They got experiment, and then the experiments from MIT. There you go, Rocket Guy. Yeah, this is pretty cool. This is a pretty awesome mission. There's a reason why we popped in for it. And then I believe there's a NASA Artemis mission or Artemis payload on here. I think. Chat, refresh my memory because now I'm second guessing myself. The Prime 1 mission is on the lander. It's not on the hopper or the rover, correct? Yeah, Lunar Hoppy. That's right. Yeah, it'll deploy a small hopper that's going to hop around on the surface.
Because they know how stressful it
Hey,
is for
Jonathan.
the team as they're coming in for a landing to make it, and hopefully it'll go right. But it is really, really hard.
The drill
to make
is the
sure
Prime
that
1
all
mission.
The systems are
It's on the
working
lander. Yeah, that's
seamlessly
the
and
third one.
perfectly,
Cool.
And that as they
Thank
get
you, Rocket.
closer and closer to the lunar surface that
All right.
the rugged terrain that they're about to land
Let's see what
on,
we got.
it all works out. And the South Pole is increasingly
What's the hopper fuel?
challenging with the
Hypergulls,
very
if I
deep,
saw the pictures
craters
correctly.
that are there. The
Virtual.
low level of light and the angle of the sun make that even more
Yeah,
challenging.
there you go, James.
So it's harsh.
All in
It's
good
harsh.
time.
It absolutely is, and it's just even more impressive when the teams then are able to land.
This is a precursor
Janet,
mission
can you
to
tell
it,
us
Mac.
how
Yep.
these commercial then lunar flights that are part of the agency's CLIPS initiative, how are they helping us then in our own Artemis missions when we
It'd
send
be limited
humans
no
back to
matter
the
what
moon?
fuel
Yeah,
you're
so
using
I
virtual.
consider them part of the
Is the
way
moon really
bigger
made out of
Artemis
cheese?
missions as we're going
I don't know,
back
maybe
to
we
the
should
moon
find
and
out.
then onto Mars, that we talk about all the time. And so CLIPS, the Commercial Lunar Payload Services, I just think it's a brilliant partnership between NASA and innovative companies
Dennis,
to come up
what's
with
up?
their own concepts and ideas and help put forth science and instruments
Rodeo, for
earlier
Pete's
than we're
sake.
going to be able to get humans on the moon. And we'll be able to learn a lot from these instruments and payloads that we're deploying. Things like
How does a hopper deployed by the lander not
water
interfere
ice?
with the
Maybe
lander
we
when
can
it hops? What a
find,
bunch of regolith get
some
kicked up?
water
It's
ice,
tiny. It's a small boy. Not
different,
nearly as much as the
roving,
lander. The hopper is
mobility
maybe this
techniques.
big.
Of course, looking at all
It's a
the
little
lunar
guy.
resources and the drilling, drill baby drill that we're going to do on this mission. So all of that we're going to be able to apply to
Did the interim NASA
Artemis
administrator just say
when we
drill,
get
baby,
humans
drill?
back on that.
How's Boca?
On
Nice.
on
The
the
weather's
surface
nice.
of the moon, and then as we go out to Mars. And again,
Really?
I think CLIPS is a brilliant
Really?
partnership.
What-
and I
what is
mentioned,
happening right now?
I believe this administration
Oh,
talks
dear.
about America first.
Oh,
and I think the
dear.
way we can do it is by bringing along industry and
keep it
really
cool on me,
dominating
guys.
the space,
Keep
whether
it-
it's
she
low
plays
Earth
Kerbal
orbit,
for
whether
sure.
it's cislunar, or whether it's on the surface of the moon. I think
Oh,
we will
dear.
continue to push boundaries and make sure that we are first and retain leadership in space.
Not missing
You know,
the
a lot of
snow. That's
exciting
right,
science
Tyler. I'm
ahead.
not. It
Janet,
is.
thank you so much for joining
I
us
was out in
today.
shorts and
Now
a
we'll
t-shirt
send it
this
back
morning.
To Leah and Josh.
Thanks, Antonia. It's time to buckle up, space fans, or lean forward in your chair. We just heard the
I'm
call
already
out for
leaning
90
forward.
seconds for time of ignition for PDI. Let's go ahead and open up those operational channels so that folks at home can listen as we go
Teach.
in
Oh,
towards PDI.
I mean-
Yeah, that's a braking burn coming out of orbit,
I
trying to slow
mean-
down about 4,000 miles per hour.
Yeah, PDI stands for Powered Descent Initiation. So this is really that final commitment that we are coming
Do
in
we have any
for
updates on when
landing.
Starship
and
will go?
everything is really
Soon.
going to happen in
60
rapid
seconds.
succession after this 11-minute burn. Now
It will
just
go
60
soon.
seconds away. The rest of the sequence is only about
Swag,
2 minutes.
27 months, thank you.
Break that down for us, Josh.
That's right. It's going to be rather quick after we get through this PDI.
We haven't
You're
heard
gonna
anything,
hear
John,
Josh
but I mean,
call out for 45 seconds.
like I'm looking out the window. The stack is there. They stacked it. I don't think they wouldn't stack it if they didn't have any intention of launching it sometime soon. That, and we do have a soft roadblock at the soft roadblock is up going to the pad. So they don't have hard roadblock yet, but yeah, that's a good sign. That's trending in the right direction. So soon.
We might be
AFM is in exec mode.
I was just about to say we're listening
Okay,
for
here we
exec
go.
mode here.
15.
15 seconds.
RCS settling burn.
Settling burn. That's our attitude control system.
Ignition commanded.
Come on.
Ignition and main stage.
All right, let's go ahead and start our stopwatches.
There we go.
here, Leah.
Cameras are running.
We'll be listening for that max
AFM
thrust.
mode is breaking 1.
Max.
Chamber pressures look nominal.
Good calls. They're not going in at 100% here, Leah. They're
Good
going
excel.
in about 90% in case they need a little bit more oomph on this braking burn.
Again, this isn't about
Good control.
an 11-minute burn, but the engine does not cut off at the end of this burn. It just continues to throttle down
Pretty good
until we
telemetry-driven
land softly
animation
on
here.
the lunar surface.
You know it's
We're
telemetry-driven,
listening
guys,
in-
because it's
listening in
skipping.
to hear some good
It's skipping
confirmations of
because it's
data.
getting
If you
data
get
in
good
real time. You
confirmation
see it.
of
You see
data,
it kind of
that means that data is making its
every
way
once
to
in a
the
while.
viz, what
See?
you're watching right now on
See?
your screen. We do expect to lose some of those communications, especially during that pitch over maneuver at the end of PDI. That's when the lander will be changing its attitude and maybe those antennas aren't pointed directly back to Earth. It's something we expect, something we plan for. But one thing that's unique to the lunar South Pole is what's called multipath, and that's when you have radio waves reaching their intended destination back at Earth after they're taking a different route, maybe bouncing off a crater or a ridge. So we do expect less than optimal radio signals on the surface. But that's something we have to plan for, and it's something that's reflected inside the viz here. So if the viz does lose communications, it's going to continue moving in its last estimated vector. So folks at home, you might be seeing the lander touch down on the surface, but the ultimate call of confirmation and what is happening is going to come from that mission director seat. You see it in the small box on the bottom right hand of your screen. That's Dr. Tim Crane in the mission director seat today.
That's
coming up on a minute and 45 seconds since the start of the burn. Again, an 11-minute burn using the main engine aboard Athena. And if you're watching the viz and it looks like Athena is traveling parallel essentially to the lunar surface, that's because it is. This is a braking burn. Confirmation 2 minutes in, and a better picture on the viz that shows just
chamber pressure still nominal.
Continuing to get good calls.
Here we go.
But the next step will be pitch over. So during that pitch over time frame, Athena will begin to upright itself and prepare to descend down to the lunar surface.
Oh, this is cool, man. I'm getting
fired
up. I'm getting fired up. This is cool.
Can you break that down for us too?
Yeah, we touched
I am
on this
Krogi,
at the
yeah,
top
on
of the
NSF.
show,
Yep.
We are going in at
I hope they quick saved.
450 meters for PDI versus our originally planned 400 meters, and that's because we had some uncertainty and variability within the recent
into the mohole we go,
going in about 50 meters higher, allowing those flight controllers to manually confirm and screen alternative measurements.
The lines are the perspectives from the cameras, Jim.
Estimated landing time
from their hazard relative navigation and terrain relative navigation cameras.
11:30 Central Time. That's 12:30 Eastern.
Which are pointed on the different
just
axis.
About to hit 3 minutes into this burn.
Different axis of the lander.
There it is. How about that? And we're listening in to hear for things about how many kilometers uprange we may be. We know this braking burn will continue to happen until about 2 kilometers from our intended landing site.
Note,
now that intended landing site is where Athena.
Guys, check this out. Something that's pretty interesting. Note that they say distance from the moon. That's the radar altimeter. Notice it's going up and down, right? 16.2 right now, 16.3, 16.4, right? And then it'll go back down in a second. That's because the radar altimeter is bouncing a signal off of the uneven surface of the moon with craters and stuff. So that's radar altimeter right there. It's going up and it's going down, which is super cool to me. Yeah, the radar altimeter is looking, it's bouncing a signal off the ground triade. So if you're in a crater, it's going to go down, right? If it's flying over a crater, right, it'll go up and then it'll go down and then it'll go up again. And then it'll go down, which is super freaking cool to me. That's radar altimeter if I'm looking at that right.
Right around the pitch over time frame, and maybe also as well as we descend towards the lunar surface, making sure that our radios and antennas are in the right config.
490 seconds left in the burn.
When would you prefer to have an ad play? Pretty much right now.
We've been burning.
Guys, I'm going to play an ad so people get uninterrupted stream of the landing. I hate ads. I can't stand them. I'd rather you guys get uninterrupted through the landing. So I'm going to play them now, okay? Yep. I hate ads. I can't stand them. Because yeah, I don't really have a choice. If I choose one to play them, then inadvertently I can choose one not to play them.
450 seconds left in a braking.
5 minutes in.
Code for 5 minutes.
This is live, Dexvex, yes.
Again, this is a braking
We're
burn,
inside
a
of 10
powered
minutes
descent
here.
Initiation, really committing us to our final descent. Earlier this morning, we had the DOI, or the descent orbit insertion, which got us out of lunar orbit itself.
They're targeting today Panderific as far as I can tell.
Been completely
I mean, I
autonomous.
looked out the window.
So, Josh,
it's definitely the rocket's definitely there.
Flight controllers can still command on the spacecraft.
That's a good point. I mean, there is an autonomous process that is bringing Athena from descent orbit insertion, triggering powered descent initiation, and then through to the lunar surface. Flight controllers do have a few options to manually intervene. We talked about allowing a little bit.
They tried to
extra
integrate it
time,
yesterday and it broke, so they fixed
meters,
it.
400 seconds left in braking.
400 seconds left in braking. We're almost up.
See,
on
look,
6
the lunar
minutes
altimeter
inside of this burn.
has
But
gone
that extra 50
down.
meters
It was
is allowing
16.5,
flight
now it's
controllers to
16.2.
manually confirm and screen alternative measurements, as we did have a little bit of uncertainty and variability with recent landing measurements. By my count, we're just crossing about
That's right,
6
Squishchin.
minutes, Leah.
That means we're
GNC
over
175 acknowledged.
30
Another
below
guidance,
3,500
navigation, and control
kph.
mode call out there.
We are over halfway into this 11-minute burn using the main engine on Athena.
AFM is in breaking
Has
2.
to be Wolfpack, yeah. Yep,
Breaking 2, progressing through that PDI count, Leah.
But also, if Math is serving me left, Wolfpack, this is a
250 seconds left
Methalox
in braking.
thruster.
350
Cryopropellants.
seconds left
That's
in
why it
braking,
can
just
burn for
crossing
so
over
long.
the 6.5-minute mark since PDI
Which is
powered descent initiation.
pretty
This
cool,
is one
guys. Fully
continuous
cryogenic
burn
landers.
from PDI all the way down to the surface.
That's
DPAS only.
pretty good.
All right, we're still processing delta position. Those are camera measurements the lander is looking at and making decisions. One of those decisions will be
15-1, 15-2
to fly
from the
to
surface.
an intended landing region.
Why is
and
that
then
cool for us mere
autonomously make
mortals?
those decisions of a safe site, whether that's
Using
safe
fully
from
cryogenic
boulders or
propellants
steep
is
slopes,
something
or
we
hear
haven't
those
done
call-outs
much in the
after we
past
pitch over,
because
you'll
of
hear
boil off.
HDA, and
When
that's
you're
what we're
using
listening
liquid
for
methane
to
and liquid
figure out
oxygen
where
as your
those
liquid fuel and
hazards are
oxidizer,
and
you
choosing
have
your
to
landing
really
site.
have good thermal mitigation, or else the propellants will
Now
just
over 7
evaporate in their
minutes into
tanks.
the burn.
Yep, yep.
This braking burn,
300 seconds left in braking.
The APU
specifically
started.
300
Nice, Phil.
seconds
There we
left.
go.
This braking burn.
Engine is still healthy.
And great confirmation about the engine itself. That engine is bringing
GNC
us
176 acknowledged.
engine is bringing us from about 4,000 miles per hour to eventually a
I got
soft
it.
about 1
Yes,
meter
we're
per
good.
second, or about 3 feet per second landing.
And I'm catching a little jitters watching the viz here, so I think folks at home will be
Come
seeing
on,
the
baby.
same thing. Remember, this is data being streamed down from a lander that's braking about 4,000 miles per hour, trying to feed that data back 250,000 miles away,
TAL is ebb now at 5 dB.
just to enjoy a little view.
8 minutes elapsed.
Camera's now in braking 2 mode.
We are still inside of PDI, braking 2 mode.
250 seconds left in braking.
They look to be initiating a
cross
slight
over 8
radial
minutes into
out
this
component to their burn here.
Again, about
What is
an
the lander going to
11-minute
do when it
burn.
lands?
We don't expect
Deploy
the engine
things.
to reach full 100% thrust. It's really
All that stuff
a
that you see on the
throttled
sides
approach.
of the lander
This
is all
engine
different, a
designed to
couple of different
continuously
missions.
burn and throttle all the way from power descent initiation, which began 8 minutes and 30 seconds ago, through touchdown. This approach is very similar to what we saw for the Apollo descent modules as well.
Yep.
And it makes a lot of sense. If you go in at 100% and you need a little more, there's nothing left to give, right? We want to come in nominally around 90% and then have a little bit of room to play if we do
Talking
need
about
to
fuel.
increase the speed of which we're slowing down. You'll hear folks
Nice
sort of
hat.
call
Oh,
out,
thanks, Yul.
the
What's
rate
up,
of
man?
acceleration, but in this case,
Don't worry.
For us,
Don't
that's
worry.
9 minutes
deceleration.
elapsed.
Don't worry.
Crossing over 9
I got
minutes.
you. I got you, BB.
Yes, just a couple of minutes left in the braking burn, so another look forward to that rapid succession.
How
of
does the
events
lunar
that will
lander
come
know where it is right now?
immediately after
It's looking
braking
at
is
the ground,
complete. We
Kelly.
will see pitch over
Relative
begin.
navigation.
We'll be using
I'm
those
serious.
4 RCS
The
or reaction
computer, that's
control
what those
system
lines
thrusters
are.
at the top of the spacecraft
Dude,
to reorient.
Relative navigation is a computer that's been trained on images. It is looking at the moon. Just like you and I, if we were going to land, right? If we were going to land, we'd be looking out the window. Look out the window. Look out the window. Okay, that's a flat spot. Let's go and do that. That's what the computer is doing. That's how this lander knows where it is relative to the moon. It has cameras, and it's looking through the cameras, just like someone would look out the window to go and land on the moon. Oh, uh-oh. What's that?
Sonic's still showing good data.
That's the second radio. So the first one,
Don't do that to me, guys.
the first one we heard a loss of
GNC
signal.
177 acknowledged.
The second was a confirmation that the
10 minutes
second
in.
radio, we still have signal. So it's good signal.
Yeah,
good data,
exactly. It's
good
like
viz,
flying
and we're
VFR
watching the
requests. It's
show
like you don't
here
have to
along
worry
with
about
folks at
clouds
home.
up there, right?
10
Okay.
minutes into the burn, so expecting just about a minute more until the end of this braking maneuver.
Press F5 just in case, right?
We
right?
expect and plan for pitch over just about
It's
2
not AI,
kilometers
it's
away
just-
from the intended landing
it's just
site.
relative
That
navigation.
gives Athena a little bit of time to pitch over and start looking forward
Discovery,
using
go at throttle.
navigation
Oh,
sensors
yeah,
to
she's
detect
really
different
losing altitude
hazards,
now.
as well as her altitude to lower
It
down
says
to
it's
the
still
lunar
8
surface
kilometers off the
approximately
surface.
1 meters per second if all goes towards plan. There's
They have a loss of
LOS as
signal?
we approach our pitch over.
Oh, this is nerve-wracking. Come on, baby. The
We're
speed,
approaching
the
11
graphic
minutes into
looks
the
a little
burn.
sus, but the
Local
speed
time
and
is
the
11
distance look
KOS
fine.
Sonics.
11 minutes in.
11 minutes in, we heard another call out that we're
Don't
up
sync.
on Quasonics. That's a radio
Don't
system.
sync. Don't sink.
It's
Pull up.
11:26 local. I'm looking at a pitch over time at 11:27
Okay.
in about 52 seconds. So we are coming up over to the pitch over, where we expect to have some loss of comms.
So
Earlier, we talked
they're
about
moving.
multipath.
They're
It's very
going down
unique
to the
lunar
surface.
South Pole,
Their
where
altitude is
our
decreasing
radio
really, really
signals are
fast, but
using multiple
speed
ways to get
seems
to
to
the
be
same destination,
increasing
whether
here,
that's from bouncing
which
off
means
the
it's
harsh
fine-tuning its
terrain.
trajectory.
There's
So
some
the
polarity
lander's
issues
actually
down there in the
engine is
South Pole.
pointed
We
this
expect to
way,
have
and it's
a
going
weaker
this way
than
right
normal
now.
signal, but we still want to make sure we get that confirmation, Lee. As
It's
part of
1 to
that
2 seconds,
confirmation,
Bad Stewart. It's
we're
not a
gonna
lot.
safe the vehicle, figure out the status there, and then start working on pictures after everything's safe. Maybe around 2 hours after landing, we can cherish that photo.
LOS on Quasonics.
There's that loss of signal on one of the radio systems. We approach 12 minutes
5
into
kilometers off the
PDI.
surface.
Again, the engine will continue to fire, albeit it will continue throttling down as
Speed
we
keeps jumping down in
approach the
segments.
lunar
I see it. I
surface.
see it. It's just the telemetry
And a
disrupt,
reminder,
the
VIS
signal
is
disruptions.
the simulation based on flight data, but if we do lose contact with the lander, which can be expected based on the conditions at the lunar South Pole, we will continue to see projected data on this visualization.
And we're approaching G, as in ground, to 2 minutes. We expect to
2
drop
minutes
this
out.
clock here in 2 minutes and take all
Yeah,
of
guys,
our
the
commands
thing
from
started to
inside
pitch
the
over,
Nova
so they have to
Control,
realign the
bottom right
antennas.
hand of your
It's just going to
screen.
take a
It's
second,
Dr.
but they'll
Tim
get it.
Crane, our co-founder and chief growth
Okay,
officer,
less than
also
a
sitting
kilometer
in
off
as
the
mission
surface.
director for landing this IM-2 mission. Standing by for the latest information.
Oh, it says
Stay
minus
well.
500 from the moon. That's the telemetry disruption, guys. Yeah, these numbers are no good.
Quasonics AOS.
Okay, the numbers should update.
HCA.
There we go. We got an update.
AOS.
Oh, look at this! Come
60
on,
seconds
baby.
left in braking.
And approach. Landing site selected.
The relative navigation has chosen a landing site. So the cameras, they have cameras looking out of this thing right now. They're looking out, and the computer's looking through the camera and figuring like, oh, that's a good spot to land, and it just picked one.
We regain that signal. Remember,
Dude,
folks, the
this
viz
is
that
awesome.
You're watching at
This
home
is
is
so
an
good.
estimation of data. It's doing its best. That's a lot of data coming from really far away. All commands and all
Come on, baby.
confirmations come from our mission director
Divert.
at the bottom right hand of your screen.
There's no booster offshore divert here, is there? If you know, you know. Come on, baby. It's looking for a landing site. It's looking for another one.
Go and throttle up.
When it picks one, you'll start seeing the distance from the moon start going down pretty fast. Like, oh. No, guys, don't worry. This is just getting the divert out of the, it's getting the divert out of our system for the day.
Again, we are standing by, monitoring the viz just as you are at home, along with Nova Control.
We are approaching approximately the time
It has a
that
little
we
more than what they
estimated
need,
Athena would
Jack.
touch
We don't
down
have
on
view
the
levels
surface.
here.
We did hear a call out for a Quasonics LOS. That is our radio system, something we expect to happen at pitch over. That's prior to a vertical descent and terminal descent.
It's
That
moving
lead
like
us
this.
to-
How are we doing on signal?
It's moving like this, Apollo.
what
It's
you're
looking
seeing
for a
on the
landing
viz.
site.
Why don't we go
We currently are getting our uplink through Hemi-2, and we have a healthy AGC value, so our uplink is coming in strong for Talas. And then for our downlink, we have a strong EBNO at 17 on Goonhilly, and we are currently
Goonhilly.
not seeing our Quasonics.
Uh-oh.
So we are in Quasonics LOS.
All right, that's a
See our
Quasonics.
signal strong on the spectrum for Talos. I'm not seeing our Quasonics on our spectrum as of yet.
FM, what mode are we in?
Loss of signal is LOS.
17 is the last we've seen.
A loss of signal right now is not necessarily a bad thing.
All right, so that's
They-
up on one radio.
These
and then
the
give it a
numbers
loss of
the
signal
numbers
on
up
the
there are no good.
Fido, I'm looking at the Sense-Excel. Do you see the Sense-Excel reading? Let me look.
That's the mission director detecting, see if
I
the
am
lander.
seeing he sensed Excel 1G.
So that was the mission
1G.
director, Tim Crane, trying to figure out what is
Okay.
the vehicle sensing. It has 2 inertial measurement units on board. You can think of those as your inner ear. So when he's asking what is the sensed acceleration, that's what he's asking for, is what is that inertial measurement unit, that inner ear, detecting as far as acceleration.
Yeah, Allengar really does, doesn't it?
Again, as we've
make sure that
mentioned-
everybody has their buffs for UBRS.
The viz here is just an interpretation of landing.
Yeah, let's go ahead and stay on Nova control. Looks like the viz is hovering. We can't.
Prop, what are you seeing on the engine?
The engine is still in idle at min thrust. We are still seeing chamber pressure.
So we're getting good data. We heard that we have
Yeah,
one radio
I don't see
up,
anybody doing
one
this yet.
radio loss
When
of
they
signal.
when you see
We
this
just heard that
or
we have
this
Guidance solution
or
for
this,
time
that means
to
something's
go
wrong.
Is increasing, just indicating to me that it is the onboard nav state is not decreasing in altitude.
Okay, that's what we saw in the telemetry-driven animation.
The good news, the HRN laser is now ready to fire.
So we heard that we have one good radio sending down data, one that has lost a signal. We have prop.
Standing by with a manual command for landed ops.
Yep.
No recommendation at this time.
Yep, we have prop telling us that we have good data. That was someone just commanding. We heard exec mode to go into this firing mode, and someone standing by to get into our landed ops mode. I'll wait for Dr. Crane to confirm here. But if we're pulling down data, we'll see how this goes. Looks like Tim's about ready to jump on the loop and sort out what we saw on the viz versus what the folks inside of Mission Control are seeing on their monitors. It's a good reminder, too, this public channel that we're listening to here in the studio, Leah, and what people are listening to at home, at the landing party at Lone Star Flight Museum.
All right, folks. I'm showing that we are sensing lunar acceleration. So we're on the surface. Let's evaluate.
Good news.
All right, let's continue to evaluate.
Good news.
Here we
Fingers
do have
crossed, guys.
a
Fingers
picture,
crossed.
From a portion of the descent. Is that right over there?
Oh, boy.
All right, so that's a picture during braking, about 10 kilometers
MD,
up from
this
the
is
lunar
prop on
surface that
IM-1.
we do have while we wait
We
for a
can
little more
confirm the
information.
engine is still running and therefore needs to be upright. If we were in a different configuration, the engine would have snuffed.
Okay, so we
Even
have
better
confirmation.
news.
I believe that was from Con that says the engine's still running. This picture you're looking at,
I'm worried they're going to run out of fuel.
the 10 kilometers.
That's a shot
up
from the
during
lander,
that braking
Sleepy,
burn,
yeah.
That powered descent initiation, that long burn that brought us 4,000 miles per hour braking burn. Incredible shot.
Yeah, that's
there.
what I'm saying as well.
So the lander is upright. Still, engine is still on.
All right.
It
there's
has not
another
landed
view
yet.
there. Looks like from this
Interestingly
panel,
enough.
we're looking at the garage.
What happens if they
so
run
that's
out of
Lunar
fuel?
Outpost map rover inside of that
Landings are
square right there,
mandatory,
Leah.
Booty. That's all I'm going to say.
And this looks like it's probably about the same altitude, maybe about 10 meters above the surface. And one more here for everyone.
Bro, these
It's about
pictures
the
are
same
sick.
altitude there, maybe a little bit more exposure.
It's
but
just
these
hovering
cameras still run in HRN
menacingly.
mode.
Oh,
These photos
what
came
was that? I
down
missed it.
for us just a few
'Cause I was
moments ago.
talking.
Wanted
That's
to
my
share
fault.
those before we jump back into mission control as flight controllers are looking at this dynamic situation and learning
Yeah, go
more
ahead and put us in
by
landed
the
ops.
second.
It looks like we're down. We need to evaluate that situation, and I'd like to get a picture.
As they say, picture it didn't happen.
LOS.
Dr. Crane's onto it right there.
Pics or it
couple
didn't
photos
happen.
here, Leah.
FM3402 was acknowledged. AOS on Thales.
Come on,
What we're
baby.
hearing in our ears and what folks at home are listening to are not the
Mode
only
20 landed
channels
ops. Check your systems.
that mission
Engine is shut down.
controllers are working on.
go at throttle
Engine
up.
shut
It's an
down.
engine shutdown notice. We'll see what comes out of this. But they are all on different loops. Having
see you
separate
guys smiling up
conversations, so all
there.
The information that we have, that folks have at home,
Come
isn't
on.
necessarily the exact vibe inside the room. So we'll stand by and listen in.
Homeboy
to
still
see
looks
what we
confused, but
have
those
here.
two over there
I did
don't.
hear Dr. Crane call out that They are getting readings for
Alright,
lunar
folks, we're moving to
acceleration.
the post-landing core procedure.
All right, Spark, I'm going to start shutting some stuff off as soon as we can.
Copy. Can you meet me on my loop, please?
Feed lines are inerting.
All right, so
Engine
we
is
have
saved.
enough data to be inerting feed lines. That means the engine's no longer running, and it's a state to bleed off that extra pressure. This is part of that safing bit that we talked about earlier, Leah. Looks like our CEO, Steve Altimus, just stepped into the room. That's in the bottom right hand of the box here, talking to the mission director, Dr. Tim Crane. He just called out telling Spark to turn some things off.
That's right, Shaw.
That's because we need to remain in a power positive state.
It
Leah,
may
getting
have,
that
of course.
top deck solar array into a spot where we are able to charge, but sometimes you have to turn a few things off to make sure that
Come on,
you're
baby.
charging and not just burning through that power. All right,
pretty
by
cool
my
moto, isn't it?
countdown clock, it's been about 22 minutes since we started that PDI, Leah.
And again, we were anticipating landing at about 11:31 a.m. Central Time, 12:31 p.m. Eastern Time.
That was 7 minutes
It can get
ago.
tricky with communications on the lander when
Are we
you're
stopped?
in
Prop, do we have insight to tank pressure if we turn off the Mogies and the Iggies?
We would,
Sweeps?
yeah.
The sweeps?
All right, that's code for the...
If you turn off Mogies, then we cannot inert or vent the tanks.
We can bring them back up though, right?
Yes,
How are my pressures?
they're low at this time.
Well, if this is in a SpaceX
Turn off the
mission.
Mogies and the Iggies. Going.
Could we turn everything off except the vent valves?
Yes.
That would be everything except MV103 and MV303.
All right, all this activity
They're trying to
is
power down
regarding the
systems so they don't
lander's
drain the
propulsion
batteries before
system.
the solar
They're
panel
going
gets ready to
through
go.
deciding on
That's
how
what
to
they're trying to
vent it.
do.
We heard two
You
things
just got to be
there,
careful.
Leah.
You
We
shut
heard
too much
Mogies
stuff
and
off.
Iggies. That's our motor engine gimbal system, right?
Yeah,
And our Iggy's
probably
our
can't
igniter.
probably can't turn it
So
back
they're
on.
working through the process of safing this engine. At the top of the show, we talked about the priorities after touchdown. and being
PGP
safe
because
was
it's
first,
250,000
followed
miles
by
away.
pulling
That's why
down
that's
some
why we're not getting
health
real-time
status
footage here.
information,
The data
and then
there's not enough
images, and then
infrastructure
just
out there.
about
There's
3
not enough
minutes ago, we heard
antennas out
Dr.
there to be
Crane
able
go
to
ahead and say,
FM3403 acknowledged.
to
we'll
stream back a
prioritize
signal.
images.
That's all.
It's just about
literally
9
nothing more than
minutes
that. They have
after
no
the
cell phone
expected
reception
landing.
out
So let's
there,
hang
so to
tight
speak.
and
They're
continue
working
to
on
watch
that,
this
though.
problem and challenges unfold inside of Mission Control. Each one going through, finding this challenge, each one getting solved here. It sounds like they're still working through venting. the
Actually,
engine
this
system.
company, Intuitive Machines, is working on building a lunar communications array with NASA, for what it's worth.
Let's power off the Quasonics until we get a handle on what antenna we're going to pipe it through.
Copy. Quasonics is currently in idle mode.
Good enough, thank you.
Sounds like an oversight.
Quasonics, that's our
Hey.
radio. There's
Transcontinental
two
Railroad
radio
didn't
systems
get
on the
built
lander.
quick.
It
It
sounds
took
like
some time.
when we talk about that vehicle health status, we heard some things for prop. Vehicle health status includes being in a power positive state.
Spark 636 acknowledged.
So we are communicating, commanding the lander, and getting acknowledgments
working on
back
it,
that the
Driados.
lander
Yeah, exactly.
is behaving as expected. So putting those things together while we wait for confirmation from Dr. Crane, we have an engine that
You
is
have to
shut
balance
down.
power and
We are
telemetry
venting the
information.
engine.
Yeah.
Spark 637 acknowledged.
We are getting acknowledged commands from the lander.
Okay, man. All right.
Standing by for confirmation.
So it's
from Dr.
intact.
And just a recap of
They're pinging it. It's
some of the
intact. It's
timelines
just
so
where
far
is it?
today.
You got to
We
find
had
it.
power descent initiation start about 25 minutes ago.
FM3406 acknowledged.
Power descent initiation is the braking burn that really committed us to coming
The
down
radios
to
are
our
intact.
landing
Yeah, that's a
site
good way to
today.
say
We were
that.
targeting landing at about 11:30 a.m. Central Time, so about 10 minutes ago
Not a
now.
lot, John.
Again, still just standing by for some confirmation from the teams in Nova Control, and hopefully a picture that shows the status of
Come on, baby.
Athena on the lunar surface. Landing
Come
site
on.
today is Mons Mouton. It is the furthest south target for any landing up into this point.
Mons Mouton.
And pretty credible images we just went through. You know, for those to come down during
Spark
this,
638 acknowledged.
during that landing
I don't know what that
sequence,
means.
showing during that deceleration burn, just about 10 meters, I believe that was.
They're
over the
figuring out if
surface
they
for these
landed,
images.
JK. You're right. You're here right at the right time.
See who we have in there. Yep, down towards the bottom
Spark
right-hand side
639 acknowledged.
of your screen. We keep hearing those acknowledgments of the vehicle receiving our commands as we stand by for the real
Command
deciding
863
factor
acknowledged
here.
by the
Never
lander.
a dull moment,
Cool.
Leah.
We did hear that
Thanks,
they were
Rocket
going
Guy.
into
Spark 640 acknowledged.
commanded landed ops. So can you walk us through some of what that means? I know that includes safing the engine as well.
Right, so there's different modes that we need to command, right? At the beginning of PDI, we hear the command for exec mode, all right?
Spark 641 acknowledged.
That's executing
We're
the
figuring
burn
that out,
maneuver,
Nova.
right? When we switch over into
Or they're
landed ops,
figuring
it's
that
a
out.
different setting on the lander in order for us to go through those steps, safing the vehicle first and foremost, that liquid methane, liquid oxygen engine.
Yep, bring it down. Also, FM, I'd like a recommendation on whether or not we keep Talos 1 up or if we bring it down.
That was Tim Crane. That's the mission director. That's that dude over there. The dude in the foreground with the best.
It's going to be a decision on up and
It's
down
kind of
for
looking
radios
towards
based
us.
on
Bring it down
power.
for now. We're taking the same pictures.
I would not recommend powering down Talos.
Why does it seem like it's more complicated than the Mars landers? Because
He did say
JPL makes
pictures.
it look easy,
He did say
Joey.
pictures, yes.
That's why.
So
Because JPL
hoping
makes
to
this look
see, the
really
status of
easy when
Athena
it's
on the
really
lunar
not
surface
easy,
soon.
dude.
we were initially expecting pictures would take a couple of hours to come down as the flight teams
Yeah,
prioritized
Blackwall. I got you,
downloading
man.
data and safing the vehicle. But
I run a
this will
tighter
help us
ship here
better
than NASA does.
understand the configuration of
It's
the
because
lander.
the Jet Propulsion
Spark
Laboratory is
642
full of
acknowledged.
winners, dude.
Every time we hear Michaela come on the tunes
Porter,
there,
can you zoom in on this view?
Because JPL is built different.
Actually, give me the spacecraft view.
It's like
Spark
the
644 acknowledged.
the Perseverance rover is like doing a flex like this, and you might not like
No,
this,
take
but
that
this
down.
is what peak performance looks
Alright, we're
like.
gonna see
You know?
here.
Like,
looks like Tim's
Star
gonna
tracker's down.
keep powering down things that we're not using anymore. Mission director looks like he's
I mean, keep in mind,
looking up at the
Intuitive
screen, maybe
Machines
they're
is a
looking at a
private
little bit of
company.
data
It's
that
a
we
private
do not
company
have
trying to
in
do
front of
JPL
us.
things. That's why we're
Still
not like
standing
getting
by
some
for
like live footage
confirmation.
of this right now. Give them a break. This is
Well, we've heard a few steps.
This is
go
a
through the
totally
process,
private mission,
venting
which is
the
super
lander
cool. It's
system,
being
hopefully
supported
pulling
by
down
NASA,
data
which is
inside
why
of
you see a
mission
NASA
control,
logo up there.
confirming Athena's status on the surface. And then finally, it sounds like we've heard a couple
oh,
mentions of
oh,
pictures
this is
of
space.
people
I'm in
on
space.
that descent stage. And we're just going to keep standing by, looking into
Gotcha,
Nova Control
no
here
doubt.
in Houston,
No doubt.
Texas, just down
I'll
the
educate
street
people that want to
from
be
Johnson
educated. The
Space
thing
Center
is that most of
to
them are
find out the
trolls.
situation inside
Pick
of
incoming.
the IM-2 mission with Athena's touchdown. Again, that
Hey,
was
it's still
about
intact in that
nominally,
picture
the
grab. That's
touchdown
all I'm
time's
saying.
about 14
Spark
and a half
645
minutes ago.
acknowledged.
Command 645 acknowledged
in
by the
contact
rover.
with
The
the
guys,
vehicle right
the
now.
rover's
The
still
vehicle
working.
is
We
shut
just
down.
got. They're
Its
just
engines
trying to
are
figure out
powered
where it
down.
is.
We are getting acknowledgement transmissions to the vehicle.
All right, team.
we
Keep
go.
working the problem. We're shedding power as fast as we can to keep the vehicle in good health. We are generating power. We are communicating through our telemetry radio, and we are working to evaluate exactly what our orientation is on the surface.
Spark 646 acknowledged. Spark 648 acknowledged.
They're talking to it, guys. It's intact. It's just where
So
is
good
it?
confirmations there, right? We know we're getting acknowledgement. We're sending things to the vehicle.
Yeah,
We're
that's what
safing
they're
the
trying to figure
vehicle.
out now.
It's time to start
Spark
working the challenge of
647
how
acknowledged.
is the vehicle, which way is it pointed. Earlier in the show, we talked about the different antennas on the vehicle and trying to work those.
I mean, Forlorn,
but we are
if I'm thinking about
charging,
this right,
which is a
if
very
they have a
key
signal with
element
it,
to this
it
mission.
should
Looks like
be
the room's
upright.
filling up
But it
with our
seems like they have a
subject
power
matter
consumption
experts.
problem.
Just continue working on this challenge to see where we stand.
Spark
Bring them back down.
649 acknowledged.
If you see
DS is back in Lorette.
You see folks walking.
They're not
on
generating
the
enough power,
bottom
try it.
right-hand
So
of your
now we got an
screen
interesting
underneath the
problem.
camera.
Is
That's
the solar
because
panel
room's
pointed in the wrong
situational
direction?
Awareness is about a 65-inch TV sitting underneath of there. So
Is the
what
the
they're
solar panel
pointing at
covered in lunar
could be
regolith?
data,
They're trying to
could
figure
be
this out. They're not
confirmation.
power.
A
They're not
little
what's
hard
called
to
power
see from
positive.
this view, but as you
So
see people
they're generating
exiting the
power. They're
bottom
just
of
not
your screen
generating
on the
enough
bottom
power
right,
to keep the
there's
batteries
a
full.
television monitor there that's helping them make some decisions. And as we cross over, it's been about 30 minutes since time of ignition for PDI, and we just hit 16 minutes
one that they
since our
sent,
nominal
Primo, yeah.
landing. If you're just joining us, we know we are sending commands to the vehicle. We have shut off equipment that has
Oh, God, Andrew,
not
don't
been
do that.
necessary. We
Don't
know
do
that.
that.
We have an engine that has been
No.
shut off. We've commanded the vehicle into surface operations. We just heard from Dr. Tim Crane that we are generating power. We're turning things off that are no longer required. We heard one of them being the star tracker. It's one of the tools that we use to figure out Athena's position in space.
It's a little
during
bigger, Neil.
flight.
Yep.
We're in landed ops. Now we're just standing by to hear what the full situation is. About 16 and a half minutes since nominal landing time, and a little over 31 minutes since Athena commanded her final engine burn.
Spark
PDI.
651 acknowledged.
Like you said, Josh, we are
Order,
communicating.
go ahead and turn on the displays for all the antennas.
We're
Okay, so you're
communicating.
going to see everyone looking up at the screen here. So when they're calling back to order, that's actually
Spark 652
in the
acknowledged.
back left of
Daytel, that's
the
what these
bottom
missions
right
are for.
monitor. They're changing
Get us live
screens
views when they
inside
go
the
to
room,
land.
situational awareness television up front, right in front of the mission director.
Couple people are
Just
doing
asked
this,
to
guys.
pull up the antenna
careful,
configurations.
something weird
Trying to
happened.
figure out
653 acknowledged.
which one's pointing back toward Earth, which might be the best one to use towards the top of the show and during PDI when things got a little spicy. We talked about multipath, Leah, and that's something that we expect to happen on the South Pole. It's something we learned from during IM-1, quite frankly, with Odie. Being on the surface and radio waves taking multiple paths to get to the same destination.
This means not great. 2 fingers up like this means not ideal. Face touching is not good. When you see that in mission control, not great stuff has happened. I'm serious. If you see the not like this, you guys know the not like this emote. If you
Multipath
see not
exists
like
down
this,
on the
that
lunar
means something's
surface
gone
just because
really
there
wrong.
are so many different
This
ways.
is
So during IM-1, we were sending
what
out
did it
signals
do?
that were bouncing
This
off
is
the surface,
oh
bouncing
no,
off
how
the
do I
craters,
fix this?
and making their
This
way
is
back to Earth. We took I think it was a Saturday and a Sunday to learn a little bit more about the multipath situation. You mentioned, Leah, Odysseus ended up breaking a leg and then laying down gently on the surface, but that communications does create a problem between multipath and learning about those things. Inside
know
of
what
Intuitive
position
Machines'
he's in,
Lunar
you
Data
can-
Network. It's comprised of ground stations all over the globe, the
All right,
largest
Spark,
one of
that's
them
good
being
work so far. What else we got?
the largest ones down in Australia. That is the Parkes Observatory. They call her Miri Yang down there, but that really is
The
what
dish.
helped us pick up those weak radio signals for IM-1. That's not the dish we're on right now, but it seems like we do have a great
That's right.
connection
That's
from
right,
the
Jack.
vehicle. I believe that dish we're using right now is GHY6 in Goon Hilly, but I don't have that confirmation right in front of me.
AD, this is Prop. Can you confirm what is getting powered down?
Everything we can right
Okay,
now,
Renfrey.
Copy.
Okay.
They're powering down these systems aboard the lander because it does take quite a bit of energy to land, but we did hear good confirmation that we are also generating power.
Yeah, all these commands that are going to Spark. Spark is code for avionics, right? It's where our power is being allocated on the lander. And we've heard a lot of confirmations of things being turned off. We heard
You
Dr.
might be
Crane
right,
say we
Spider
are
Arc. We'll see.
generating solar power. At last check, we heard mission director call out to look at the antenna configuration on the room's situational awareness model screen. And we're still standing by to see where this is
If
going
I had to
go.
weigh in, guys, I don't think the lander's tipped over. I think it landed like on a hill. It's kind of sideways on a hill, which
Yes,
would
power
explain
down the Personics until we're ready to use it.
which would explain why they're generating power but not generating enough power. I don't think it landed on a completely flat place. I think it's landed a little bit on its side, or it's in a crater. Be quiet, Julia. That's not funny. That's not funny. I don't think it tipped. I think it's not on completely flat ground. Judging by what I see, I could be wrong, though. I could be very wrong. Thought they were using TRN. That's not a surefire victory, though, Opors.
It's about 20 minutes now since our intended landing time today. Again, we were expecting that around 11:30 a.m. Central. Teams in the room in Nova Control. That's here at Intuitive Machines in Houston, Texas, just down the street from Johnson Space Center, continuing to evaluate the status of the spacecraft.
Drummer, that's what I'm thinking.
Continuing to communicate with the spacecraft itself, and just waiting
Curveballs
for
always
potentially
happen,
a
Neil.
photo
It's
that
how
would
you
help
deal
us
with it.
confirm its orientation.
They're figuring it out. Give them a second.
I'm just going to wait one and listen in for a couple cues coming into the studio here. Bear with us, folks.
Uh-oh.
Thanks again, folks, for joining us for the IM-2 missions landing coverage. I want to go over a few things we do have coming into the studio, into our ear, that we can confirm while the folks are working inside of Mission Control on their own challenges. But a couple things that we do have that we can confirm. Athena is on the surface of the moon. The team is going through the process of powering down systems that are not required. We heard the mission director call out that we do have solar charging, so we continue to hear them in our ear that they're turning off different systems that are not required.
She's a little sideways. I don't think it fell over.
We are working to figure out the orientation of the vehicle, which is important because those are our antenna systems that will determine how much signal we're going to have and when we can start bringing around things like vehicle health data and other images that can help us to confirm. But we are communicating with the vehicle. We've heard throughout our intended landing time, through now different call-outs, making it to the vehicle. We have direct communications contact, and we would tend to bring out some more information as we continue to assess this dynamic situation inside of Mission Control. We intend to have a press conference at 3 o'clock Central Time. That's 4 o'clock Eastern. We'll do it right over at Johnson Space Center, Leah.
That's right. Thanks for joining us today.
Don't cut the cast.
Other information, if anything else
kidding
comes
me?
out on our website, as well as our X feed to keep everyone up to date.
No.
Thanks for joining us, folks.
No. Don't zoom out. What are you doing? They cut the cast.
Did they just end the broadcast?
They just ended it.
What the heck?
I don't know.
Seriously?
Like, they were problem solving the steps, and they're like, "Yeah, we're gonna go now." I'm like, "Stop it! What the heck is this?" But come on, man! Oh, that's so uncool. Now what? What are you looking at me for? I didn't do it. I know nothing. Neither do they, apparently. Anyway. Hey. So you come around in these parts often? No. Jokes aside, guys, okay, so let's review. They had connection with it. They weren't power positive, right? So having connection is key. That means the thing is relatively upright. I mean, the antennas are pointing in the right direction. They wouldn't have gotten a signal lock on it and started having it accept commands to power down components if the antennas weren't pointing in the right direction, right? So you're not power positive, which means something is weird with the solar panel. The solar panel is on the top of the lander, and it's actually tilted a little bit. It's tilted because you're at the pole, and what it's designed to do, it doesn't move, right? It's just fixed, tilted on top of the lander, right? It's designed to get a lot of sunlight during the lunar day. Lunar days usually last up, because the moon is tidally locked, they last about 2 weeks, which is basically how long the lander is supposed to be operating, right? So they were generating power. So the solar panel's upright. Everything here points to the lander being on the side of a hill. It's upright, but it's not like straight. So it's like this, right? So the lander came down and did this, right? That's what everything is pointing to, but we'll figure it out. I mean, it's not like what happened before where they didn't have any signal lock after landing and had to point the dish in a weird direction to bounce a signal off the surface to get to the antennas. They had an immediate signal lock. They weren't power positive, which means I'm pretty dang sure it's tilted. The lander's like, get rotated, idiot. No. Does that mean it's cooked then? No, not necessarily. That might make deploying the rover and the other hopper just a little bit complicated, but I think she's upright. Judging by what I saw there, it looks upright. So we'll see. It's because you're wearing a SpaceX cap. Oh no. So they do need to get power positive before the batteries run out. Yep. Das shut down the moon lander. It's all his fault. Wait, what? What did Das do? Nothing? Do nothing? Anyway, Well, that's gonna do it, I guess. I really wish they didn't cut the cast like that, but hey, whatever. Yeah, we needed Neil to drive it. Yeah, that's right. Neil would have landed it. Just saying. So remember, they landed on moon sunrise, so the light state will only get better. Yeah, but you got to shut down to make sure you don't undervolt something, right? Drain the battery too much. So let's take a look. What time is it? That was fun. That was fun covering that. So it's about noontime central right now, and we are going to start the NSF stream in about 2.5 hours, the main stream. Can you show the Firefly landing? Oh, you wanted to see that. Yeah. Here. I'll show you. This is pretty good. Here, check this video real quick. I really just hope people don't think this is Intuitive Machines when I show it, but you get the idea. Here, take a look.
The path to the stars is no longer limited to nations alone. Firefly is building the road to the next frontier.
So this was the Firefly lander from, a couple of days or 4 days ago.
Let's reach another
Check this
mission
out.
milestone. Together, we created a moment in history.
They're looking okay, Smoked. We'll see. Hey, Canuck, what's up? Yeah, it was, wasn't it? Yo. Hopefully we see these from Intuitive Machines. Come on, baby. So watch this. Check this foot. Dude, if you haven't seen this, man, you're in for a treat. Great beat. Dude, the shadow! Yes! What the frick, man?
All Khan, Chief Engineer on Ops. Y'all select the landing. We're out to go.
That footage is crisp, man. That footage is crisp. It's so ridiculous, dude. So this was Firefly Aerospace. This was the Blue Ghost 1 mission. We just got done watching the Intuitive Machines mission. Hopefully we're going to get some footage like this from them very soon. That'll put 2 lunar landers in the span of 7 days on the moon. I personally think Athena's upright, but we'll see. Oh, dude. Look at how the dust moves. Oh, that's so cool. Yeah, well, there's a Japanese lunar lander, Slim, that did that. It popped the little rover out during landing, which is pretty cool. That's pretty good stuff, man. Anyway, oh, wow. Pretty cool, huh? All right, guys. So here's the deal. That was Firefly. That was Firefly Aerospace. Hopefully, like I said, we get to see some footage from Intuitive Machines like that sooner rather than later. Check out this latest video of the regular test. Yeah, I will. All right, so I got to go get ready for the NSF cast. NSF cast, the main cast for the Starship Flight 8 mission will be happening in about, give or take, about 2 hours. Actually, let me double check the start time just so I know. Give me one moment. Yeah, it should be around 2:30. We'll see. 2 hours, give or take, for the main cast. So I'll see you guys then. I hope you enjoyed the Ariane 6 CSO3 coverage and the Intuitive Machines IM-2 mission coverage. We'll see. We'll see what happens. I personally think the thing's upright. I think it's just on a hill. But who knows? We'll see. We'll see. Have you received any cheesecake yet? We don't do that, please. Don't do that. So I'll see you guys for the NSF main cast, which will be rebroadcast here on the Twitch stream. And I will have both chats up and running. So I'll see you guys then. Thank you very much for watching. Let's see how Flight 8 ends. I really hope I don't eat those words. I'll see you in a little bit. Thank you very much for watching.